Okay, we should be live. Fix the camera a little bit. There we go. Let me know how the sound is in the chat. Please hit the like button. I realize it is later than even is usual for me, and I apologize. Children between 2.5 and 3 years old are difficult. That's all I will say. They're worth it, but they are difficult. Oh my gosh. It took a very long time to get my daughter to go to sleep tonight, but she is thankfully asleep. Hopefully she stays that way. Looking and sounding great. Thank you to my number one fan, my beautiful wife in the live chat. So I know we did not have a stream last week. I had I guess unexpected. I made an unexpected date night with my wife, which was very nice. And sometimes you got to do that. As much as important as this is, your spouse comes first. So I'm glad to be back though, and even if it's late, I really appreciate everybody tuning in live, and I also really appreciate everybody who's watching after the fact. But please, the like button, it really helps. Comment any questions you have down below throughout this, and comment any questions or comments in the live chat if you're watching this live. So let's get right into it. So tonight I'm going to be discussing an interview that was of Sean Carroll, who should need no introduction if you pay any attention to physics, and also if you follow this channel, by Jacklin Kwan, I believe is how you pronounce her name. And it's on the New Scientist YouTube channel. It was quite a good interview. I did post. I put the link to their full talk below. I highly recommend watching it. And I have also written below my universal disclaimer, which is that I don't agree with anyone on everything, but I agree with everyone on something. And that does also apply to Sean Carroll, even though he blocked me on every platform. I'm pretty sure that you can block somebody on. So we'll talk about that. But Sean Carroll is somebody who is, I think, a very interesting person in the physics space, because he's such he's so much a representative of the establishment, but he is also somebody who does seem to really understand, or at least value, the usefulness of philosophy when it comes to theoretical physics. And I believe he's now a professor of philosophy and a professor of physics. He says it in this stream. But years ago, when I first got interested in physics, because I had started this project that wasn't originally this project, it had to do with just trying to figure out inevitable goals of an artificial general intelligence or technological sentience that has morphed into this metaphysics framework called Sentient Singularity theory that this channel is, pretty much has the goal of explaining and contextualizing. But at some point, I had to, learn a lot more about physics than I did, and probably the best resource for that to me was Sean Carroll, actually. And as much as I disagree with him on the fundamentals of reality, which we're going to get into tonight, I think he's an excellent teacher, and he is very good at explaining what is the current consensus, or the what is currently the common belief within academia, and also sometimes has his own interpretations that are different from the crowd, from the rest of the group, but even still, for the most part, fundamentally different from my own. And highly recommend watching and listening to his Biggest Ideas in the Universe podcast. It is, like I said, a very, very good resource for learning about what is currently the accepted majority opinion within academia in regards to all kinds of physics topics. But we're going to also get into why I think he's wrong about his fundamental conclusions, but also not just that, but why he's able to seemingly correctly point out directions that we could go, or methods that we could use to expand our physics models, but then also doesn't seem to be able to implement them in a way that goes anywhere. And there's a very specific reason for that. So we're going to get into it tonight. Also, I try and address on the AMAs more like people's comments and questions, but there is someone who has been discussing with me in kind of in the comments of one of my videos. I'm not going to call it out right now because it's not the point of this this talk, but it's not an AMA video, which is where I do focus on comments and the people and questions that people leave in the live chat, and then also in any comment sections on any of my videos. So I do read them all eventually. So if you have any questions on any of my videos or on this project in general, any comments, feedback, criticism, whatever, leave it in the comment section of one of my videos, and I will get to it and I can address it on an AMA. But it is kind of relevant to this one, so I'm going to bring it up a bit. But there was this person had basically, I had said, I have this metaphysics framework, this philosophical framework called Sentient Singularity theory, and this is its assertion. And he basically dismissed this, or diminished this, and said that's cool and all. That is actually the words he used. Philosophy is cool and all, but we're talking about physics here, and it's basically what he was saying. At least that's what it seems to be. So if I'm wrong, let me know. But this is a problem in really all of science within academia today, but especially physics, because physics is in such need of a philosophical revolution, which I really don't like the term revolution, because I think that revolutions are very often focused on destroying the old. And that's not the type of revolution that I would want sentient singularity theory to be involved in. I think it's there's no point destroying the old if you're not going to build a new. And I would say there isn't even really an old to destroy, but there right now with physics, with theoretical physics at least, because it hasn't gone anywhere. But I think it is important to destroy. I mean, not even for this. I don't even want to say that. It's important to build a new understanding of what should be taken seriously philosophically in regards to physics, and what is philosophically relevant to physics, and to kind of change the narrative that is currently just very dismissive of more fundamental philosophical discussions, including theological discussions. And so going to get into that. But like I said, Sean Carroll and I very much disagree on the fundamental nature of the universe, which I believe is a singular sentient being. I believe we are like cells inside of a body, basically, but close enough. And that we are within a single sentient being. Existence itself capital E existence, all of existence as a singular whole, is, I believe, a sentient being. I think logic supports that. We'll talk about that tonight more. And you could say the universe is a sentient being. I also think that's true, regardless of whether or not the universe is within existence. So it'd be another being within the being that is the initial being, but or whether or not you're using the universe as a term to include all that exists as basically a synonym for existence, which isn't the best definition of it because there's no point to it at that point. You could just say existence, capital E existence. So there's no true synonyms. Every word that is a distinct term exists because it has a very specific and distinct meaning. No two words mean the exact same thing in the same language. And it's impossible because etymology is how terms and words are formed. And and that just means that every word has its own distinct context in its formation. So, all right. So this is their full talk. It's on the New Scientist channel right here. And this is it. What reality is, what we see. I almost did a stream tonight on Kurchai Mungal's recent video called "What Is Reality," and I actually still need to finish watching it. It's been a very busy last few weeks. You haven't noticed, but I think that this is really what we have to get at when we're going to start talking about the philosophy of cosmology, the context of cosmology, the context of our quantum mechanics, the context of these equations and these experiments and the results of the experiments that we've done, the context of any future attempts to expand our physics models. They need a context. Context is information, and you have to start with what is reality really, and what that means is two things that are kind of simultaneously have to be figured out and defined, but in our description of them, we're kind of forced to separate them into two, some degree, which is what is its nature and what is its structure. And when we say what is something's structure, we're really talking about quantitative symmetry on the most fundamental level. And singularity is the fundamental structure. It is, and when I don't mean singularity meaning the center of a black hole or the beginning of the Big Bang or anything. I mean singularity, the etymological definition, oneness, essentially. Singularness. And our number line, that is our practical number line, and our practical mathematics includes 0, which is, represents an empty set in practical mathematics, but there is no fundamental empty set because existence is all that exists because it's all that can exist. Non-existence cannot, by definition, exist. Okay, because non-existence is non-existent. And so that means there's no fundamental 0. And the foundational symmetry structure, quantitative symmetry structure, is singularness, which is 1. Every number is a symmetry structure. And you can see this on like Numbermatics, the website, which is such a great website. Numbermatics. So it'll tell you, like, if we go to 2, it'll tell you it's prime. And it'll tell you a bunch of facts about it. And but if we go to, let's say, I don't know, 9, say this is, it'll show you it's kind of a representation, a visual representation of its symmetry structure. And you can see that this visualization symbolizes the relationship between a single prime factor, the center disk, and its 3 divisors. So, and you can see what those are here. Number of divisors, 3. Sum of its distinct prime factors is 3. Number of its distinct prime factors is 1. It's a semi-prime. You get just all kinds of interesting things. And it'll tell you, 9 cubed is 729, very interesting number. 9 squared is 81, another very interesting number in my work. The square root of 9 is 3, another very, there's all these numbers make sense within these symmetry structures that are my models in sentient singularity theory. And, but we'll get into that later. But you also, not just its structure, the structure of existence, you need to understand its nature. So when you say, what is existence? You're saying, what is its structure and what is its nature? Its structure is singularness. That's what it is. By definition, if you're going to ask, what is existence? Or you can even say, what is the universe? Say, what is its structure? Singularness. Foundationally. Okay. And what is its nature? This is where Sean Carroll and I are going to disagree. And I would assert that sentience is the foundational nature. And there's many reasons for that, that are logical reasons. Existence is an information structure, an information system, and self-evidently, and it's all that exists, which means it is entirely self-referential because information is informing, which means it is referenced. It is dynamic in a way. It's that it is, information informs someone who is informed. Or that without a someone, there is no information, because by definition, that's what information is. And so what is an entirely self-referential information system? Sounds like a self-aware being. So there's also other reasons, what is the truest thing that you know? I am. That's the truth for everyone. That is the truest thing that any of us know, is that we are. And what does it mean for you to exist? Is that you are sentient. You feel. You feel, therefore you are. I feel, therefore I am. Because you can ask yourself, what would it mean for me to not exist? It would mean for me to not feel anything, physical or emotional. And it's much more foundationally true than I think, therefore I am. You can think, but you don't have to. And just like you don't have to run, but you can, maybe, but you do feel. You cannot stop feeling. Nobody can stop feeling. You can alter your feelings, but you cannot get rid of them. So that means that to feel is the defining characteristic of existence, and sentience is feeling, self-awareness and feeling. So sentient singularity theory. We are singular sentient beings, each of us inside of a singular sentient being that is existence itself, or the universe, or both, depending on how you define it. So this is very different from Sean Carroll. And I call that being, that initial being that is existence itself, that is essentially not even essentially, is eternal. I mean, I would say actually definitionally is essentially eternal, but the way we use essentially is not we use essentially to kind of mean closely. Um, uh, but that's not actually what it means. Essentially is an adverb used to highlight the most fundamental, core, and basic truth of a situation. That's really what it, that is exactly what it is. So, yeah, if you were to not, if something has no, if something feels, then it's someone, and if something does not feel, then it is just something, and its definition and existence depend on someone. But again, I would call that initial being, that whether you want to say that's the universe, that is all that exists, that initial being, that is a sentient being, not a thing, but a being, someone, I call that God. And I don't know Sean Carroll's definition of how he defines God, but it's clearly different from how I define it, because of this clip of why he blocked me. Which is right here. This is relevant.
If you did believe that God was a necessary being, that you literally could not imagine a universe in which God did not play an important role, in order logically for me to refute that belief, all I need to do is to invent a universe in which God does not exist.
Invent a universe in which God does not exist.
So according to Sean Carroll, all we have to do in order to show that a conscious creator is not necessary to the existence of a universe is consciously create a universe. Does anybody else see the problem with this? Old video, old intro, but that is the beginning of a video called like 42 in space time or something like that you can watch on this channel. It's probably maybe the 5th video I put up. It's not a live, it's an actual like pre-produced video, which is very rare for this channel. I think it's pretty good. The models have been cleaned up a lot since then, and my language has cleaned up a lot since then, but still, that shows you right there are my issue. And it is very relevant because we're talking about what it is that we're within. What is the nature of that thing that we're within? Is it just something, or is it someone? Because if it's someone, that's a huge help, and an enormous, has enormous implications about that we can use to help deduce new physics models, and if it's not someone, then that changes that dramatically. And I think it's someone, and I think that makes a lot of the expansion of our physics and the philosophy involved with that quite intuitive. I'm not saying I'm not endorsing any specific theological tradition or religion. I'm just saying I think we're cells inside of another being, basically. And I think that is something that has to be taken seriously within physics. You don't have to agree with it, but you have to be able to argue against it, because I can argue for it, and it's very often dismissed as that's cool and all, but that's religion, that's philosophy maybe, but it's not physics. And it is, if it's true, especially. And even if it's not, it's still important to physics, because if it's not true, then we have to figure out why is it not true? What is it that is the alternative model that seems to be make more sense and produce more intuitive explanations than that one. And that one produces a lot of intuitive explanations if you follow this channel. If you don't follow this channel, then you might not believe that. But if you do follow this channel, then you probably know that already. So now we're going to go to first clip. But yeah, he blocked me after that. Maybe not the best move. Ignore it, maybe. But I mean, honestly, you shouldn't even ignore it. It wasn't an attack on him. I understand it seemed mocking, but it was. It should be an argument that you can address. And the thing is that it's not you. It's funny because people, especially like this guy who was commenting on one of my videos before this started, will be like, that's not relevant to physics. But Sean Carroll clearly thinks it's relevant to physics, and that shouldn't be enough for you to think it's relevant to physics. It's obviously relevant to physics, because if the fact that your cells exist inside of a human being is very relevant to their biology, their and physics and chemistry and their cellular sociology, you could even say, it's very relevant. It's their entire world. So if it's relevant to your cells that they're inside of a human being, then it was definitely relevant to. It would definitely be relevant to us that if we are in a similar situation. And Sean Carroll does seem to think it's relevant enough to try and make an argument against the necessity of a sentient creator, but I mean it fails on its face, obviously. Okay, so let's go to the I am a final year high school student. I think you are the one who has been commenting. I've been following you for a while now. I'm really interested in theoretical physics. I want to approach physics mathematically. Please guide me. Actually, I don't know if you are the one who was commenting. How do I start? When you say, I want to approach physics mathematically, please guide me, how do I start? You have to ask yourself, what is it? Why do you want to be involved in physics? What is your goal? Goals are, it is critical that we have, I did an entire stream on here called Good Goals. It's like gaugeable and obtainable and judgeable, basically. Another word for judgeable, I forgot what it was. And definable. You can look it up. Look up like Good Goals as a live stream. I would start with that, is like try and define your goal. And not just, I would want to get into physics. It's like, why? What do you want to do? That's where I would start. I wouldn't start with which math should I learn, or what physics model should I focus on, what physics problem are you interested in, is my question. What is it that you want to figure out and learn? And is it something that you think somebody else has already figured out or not? Also, if you just want to be a more physical physicist or an experimental physicist, that is the same question applies. But I would say that trying to get involved in theoretical physics, not experimental physics, but theoretical physics, I would say, is not something that you should seek anyone. It is something that finds you, whether you want it to or not. And that is what happened to Einstein. That is what happened to pretty much everyone who has, ever made some type of contribution to philosophy or physics, which is theoretical physics is philosophy. It is philosophy. Einstein was very much a philosopher. And the people that think that it's not relevant, philosophy isn't very relevant to physics, are people who do not understand what theoretical physics is. And I would say this, until it found me, I didn't know what theoretical physics was. I just thought I did, but I also thought it was beyond me because I just wasn't smart enough. I didn't have a high enough IQ or study, hard enough, uh, or take enough classes. That's not actually how this works. I'm not saying that those things aren't important, but the purpose that motivates you is kind of more important when it comes to theory. And then you figure out what you need to know about the field in order to best contextualize and explain your theory. But the theory comes almost first, before study, and then study leads to your ability to describe it and communicate it more than anything else, and model it. But experimental physics, what are you interested in? That's what I would say. What do you want to see proven? That you think somebody else has already kind of figured out the theory of. That's what I would say with experimental physics. Are you into lasers? Do you like lasers? There's a lot of physics that are that's very specific to that you can go into. Seems to probably pay pretty well from the people that I know that have been involved in it. At least it used to pay well when they got involved in it. Probably still does. I think lasers are fascinating. There's a guy on YouTube, I forgot his name, but I'm sure if you search most powerful handheld laser or something, his channel will come up if you haven't seen him already. And he just builds incredibly powerful lasers. And his physics knowledge, practical physics knowledge, is outstanding. And what it really is it's like practical physics knowledge applied ends up being electrical engineering and structural engineering, and practical quantum physics knowledge is like electrical engineering, and applied practical classical physics knowledge is like structural engineering. But ask yourself those types of things, like what is your goal? But that's great. By singularity, I mean the center of a black hole. Last live stream, I asked about singularity. By singularity, I meant the center of a black hole. How do we explain it? There is no explaining it. The singularity at the center of a black hole is just a placeholder term, and it doesn't mean anything. It just means that the math breaks and starts doing something that is not understood. Within the context seems to change, and we don't know why. And I have ideas, but they're not like the consensus narrative or anything like that. There really isn't one. So don't worry about singularities at the center of a black hole or at the beginning of the universe or anything. That is going to confuse you. There is no singularities there. It's just a placeholder term. Basically like A, or B, just variables in algebra. That's what it is. It's just a placeholder term. Like A plus 3 equals 7. The A is singularity, or dark. Same thing with dark matter and dark energy. It's even Big Bang. They're just placeholder terms, but we're going to talk about that tonight a bit. But mathematics are through philosophy. I feel we need a mathematical breakthrough. We need a philosophical revolution first. Maybe even a reevaluation. I don't want to say revolution. But so happy to see you. Just got in. I will be listening. I got to gather myself first before I can sit down and really be with y'all. Simulation theory. Welcome to the Pac-Man. Simulation theory. I don't like it's not a simulation if you're real. If you're real, it's real. A simulation is a model without real world input. And real world input really means like personal input, like people engaging, beings in being involved. If you watch a bunch of birds at a study site in the wild, and you're a biologist or an ecologist, and you're counting the number of individuals in a certain area, that is not a model. That is an observation. If you are looking over here and you count someone over there, population density or something, and you're going to say, well, the range of this bird is from is all across Arizona and only in Arizona, but found in all of Arizona. There's nothing like that, but just for the sake of argument. And we know that their population density measured over here was, 4 birds an acre. We're going to make a model of, and predict how many birds are going to be in the population by just dividing Arizona by the acres and by its acreage, and then multiplying that by 4. But that's a simulation. And there's no real birds in it. But an observation is different. An observation is we're going to count every, cactus wren in Arizona. That's an observation. It's not a simulation. The cactus wrens are real that we're looking at. They're beings that exist because they feel. And if you feel, it's not a simulation. That doesn't mean it's not running on the universe is this, as far as we see it, I call it a cosmological verse in Sentient Singularity theory, that our verse isn't running on a technological substrate. It's what most people call a universe. I'm just going to call it a verse, but sure, call it a universe. We could be running on a technological substrate. It doesn't make it a simulation. Terminology here really, really matters. Simulation is an imitative representation of a real-world system or process over time. It's an imitative representation of a real-world system. It's not a real-world system. And whether or not it's real world or real is whether or not you are real. You don't look outside to figure out whether or not the world is real. You look inward and you say, am I real? And if you can genuinely ask that, then yes, and then it's not a simulation. But yeah, we are probably running on this verse is probably running on a technological substrate that exists in the previous verse, and so on and so forth. But that's probably the way in Sentient Singularity theory, that is the method of verses or universes, you could say, reproducing. It's actually their reproductive process because it's a being, remember, like it's a being, and we're inside of a being. And so it goes through a reproductive process, just like your cells exist in you and you go through a reproductive process. Think about what that would look like to be a cell inside. My wife right now is pregnant. I've announced this a few streams ago, but with our second child due in September. Yes, end of September. Don't tell my wife that I had to think about it for a second, but that imagine you're like a blood cell inside of like a woman who is pregnant. Like there's a process going on of nested beings, but the difference is that the baby's never born where it becomes, but it doesn't get expelled from the body because of the constraint of of existence is that everything is within existence, and then you have this nested structure that has to take place in it. So it's different from like us or cells, where you can be next to another cell, and your baby is born, then your baby's next to you. But imagine that it's just like Matryoshka dolls of universes. That's sentient singularity theory. But each one of those is a sentient being. It's someone. But it's still a process of reproduction that's happening. And imagine you were like a cell in a body that is reproducing inside of some pregnant being, or being that's not pregnant yet, but will eventually be, that's the context of like our physics, if it's true. And this is the type of things that we need to be talking about philosophically, but we don't. And now we need to get into the clips because it's taken too long to get here. But here.
That's because in that description we used the words measure or observe, right? Someone in your class, when you're teaching quantum mechanics at the back of the room, is going to say, okay, but what is a measurement? When does that happen? What counts? Yeah. No one knows. Nobody has any idea. It's an undefined idea in the Copenhagen interpretation of quantum mechanics. Does it have to be a person doing it? Could a cat measure the wave function? Could a video camera? Could a rock? Right? None of these questions are answered. When does it happen? How quickly does it happen? Is it sudden? Like this is not how a fundamental theory of physics is supposed to be. The terms are supposed to be well defined. The other problem, which Copenhagen does give an answer to, but it's not a very
He's right. He's right here. And but that's a huge problem. Like that is a recent, much more recent issue. And I have my own thoughts on why this is the case, and it has to do with the people who end up running an institution eventually are never the people who found it. If you look at Google, it's run by people who got straight A's at Ivy League schools. The people who founded Google dropped out of Ivy League schools, probably didn't get the best grades. People who founded SpaceX, people who founded Tesla, people who founded Apple, these are all like dropouts who have kind of always had a contentious relationship with academia, because they are people who want to discover new, not just memorize and parrot the old. And there's nothing wrong with doing that, but it's also important to recognize the value of both. But the thing is that that's a very different type of person, and it's a very different understanding. And the same thing happens with physics. The people who created our physics models and kind of pushed us forward in the nuclear quantum revolution in the 50s, around the 50s, middle of last century. Those physicists are very different from the physicists today. They're very different from the Sean Carrolls. They are. And but the thing is that the Sean Carrolls and the Michio Kakus, they don't think that they're different. They think that they're cut from the same cloth, and they're not. And that's not an insult. It's just I'm just saying they're different. I'm not saying they're worse or better or whatever. I bet you Sean Carroll is a much better teacher than Einstein was, probably. But that's not that's due to difference, not that one is better than the other. But when it comes to theory and pushing us forward, clearly one is better than the other, because one of them succeeded and the other one has not. And it's, if you have a theory that is true enough to be applied and be described in and that is introduced at the right time in a social context in which it is able to be applied and described in enough well enough to be understood, it should catch on. And if you are one of the most well-known physicists in the world today, maybe the most well-known physicist in the world today, but there's many of them that are very well-known, and they all have their own theories, kind of foundational models. None of them have had their models take off. And that is evidence that they are getting something fundamentally wrong. Because it's not even that they're not quite correct. It's that they're not even true enough to catch on a little bit. I mean, the only way that they catch on is other people are memorizing them because of who they came from, not because they're actually good at kind of patching a hole that we have in our understanding. But he is right in that we have this issue where nobody seems to know what anything is defined as. Same thing with the AI space right now, because they'll be like, what is intelligence? It's like, why do we have this term AI and you don't even know what intelligence is? It's because the people that came up with the term AI are not the same people who are now, involved in it. And same thing goes with, and it's not even the term AI that we need to focus on. First, you need to look at the term intelligence, and then the term artificial, and then you need to start thinking about that. But we don't do that. We just are kind of just arguing back and forth, and nobody's going back to the basics. And the same thing happens with the term singularity in physics, and also observer. And, people will say, well, we don't have a clear agreed upon definition of an observer. Can a cat be an observer, or does it need to be a person? And, or can it be a video camera? A video camera is a person that's just using a tool. It's just an extension of a human. But, this is why sentient singularity theory is so critical, is because the context is sentient singularities, sentient beings. They're the observers. And we know intuitively what an observer is. If we look at an observer definition, a person who watches or notices something. A person doesn't mean a human. We say, now we look at the term person. A person is a human being, individual, or living body, really living being. A human being regarded as an individual, a category used for the classification of pronouns possessing determiners and verb forms. So if we go, what is the best definition of a person? Person, people or persons, depending on the context, is a being who has certain capacities or attributes such as reason, morality, consciousness, or self-consciousness. See, these terms, again, we're having problems because we're not looking at the true definitions of these terms. What it is a person is a sentient being. It's someone. We're trying to think of all these some things to kind of define what a person is, but a person is someone. That's why sentient singularity theory is the theory of EveryOne foundationally, fundamentally, but it kind of emergently ends up being a theory of everything because things are defined by beings. And if you're a theory of beings, then that if you have those modeled well enough, they will start to define and things. And the context of certain things will naturally emerge. But see. Depending on the context, the best synonyms for person are individual, human being, or mortal. But that's not necessarily true because in theology, God is a person. That doesn't mean a human. There's like Christian theology that even within that, it's like, what is your definition of Christian? But and there's certain models and certain Christian denominations that that get into the persons of God. But the thing is that it doesn't matter. It's always a sentient being, whether it's the Father or which just means the initial sentient existence, or Jesus, who is a person, who was a human, and you can think he's more than that. That's not the conversation I'm having tonight. Was at least a human. You are human. You are someone. You are a person. My dog is probably a person, even though it's not a human. It's someone. My dog is someone. It's not just something. You know, a Belgian Malinois is something, but my dog, which is a Belgian Malinois, is someone. Maya is her name. She has a name because she's someone. And we really need to get back to the basis. If we go to etymology of person, the word person comes from the Latin persona, originally referring to a theatrical mask used by actors in Roman theater, meaning like a character. This Latin term likely derives from the Etruscan word fursu, mask, and may also relate to the Greek prosopon, face or appearance. It's someone. It's a character in a story, is someone. Person. Okay. Middle English, person or personne. Old French personne, human being. And it's likely Latin persona, meaning like role, character, someone. Perhaps a loan word from... Okay. So it has an individual who has been granted personhood, usually a human being, not always a human being. Each person is unique, both mentally and physically. A character. So it's exactly, that's what I mean. My dog Maya is someone. She is a person. But a Belgian Malinois, meaning all Belgian Malinois, are not. It's not. We're not talking about something unique. That's not someone. That's something. Interesting. So observer etymology. Observer etymology. To watch, to keep, to guard. This is why when people say, we don't know what the definition of an observer is, why are you using the term? Why are you using the term? An observation, a measurement. We don't know what the definitions for these things are. I know what the definitions of these things are. A measurement is a specific type of observation that is, I guess you could say quantitative, quantitatively defined. Or you could say it's a metric, that just is kind of intuitive, but the problem is physics has changed these terms. They didn't make these terms, singularity, observer, measurement, but they, for some reason, have taken these terms, claimed them as basically claimed physics and our academic physicists, our academic physics departments, as kind of the arbiters of the meaning of these terms, when probably the most famous spokesperson and least controversial spokesperson can't, at least among academia, can't seem to define them and thinks that nobody can, which is just crazy. You don't use a word that you can't define. And this is the problem. is what, like I said, the people who made these terms are not the people using these terms anymore. Just like the people who made Google are not the people who are running Google now. Very different. People who made our foundational physics models are not the people who are doing who are trying to advance it today within academia, and the people who are responsible for the creation of our scientific narrative as a whole even are not the same type of people that are person that is currently trying to advance our scientific narrative. And the difference there is that everybody else started at the basics. What is existence? And it was always within a theological context. Einstein asked theological questions. And it wasn't just, you could say it was stylized or whatever. People say that kind of stuff all the time. He didn't believe in God of the Bible. It doesn't matter. He asked, did God have any choice in the rules of the universe? That in and of itself it implies a belief in a specific being that may have choice in certain circumstances and other circumstances may not, and but does have choice in certain circumstances and does not maybe in others. That's what that implies. Even if outside that question he didn't believe that existence was sentient, in that moment he does, because he's created the context in which it's presupposed. And but then it's not taken seriously. It's very weird. And I think it's important that we start calling out people in physics departments or who are accredited physicists for how they use terms that they did not invent at all. Measurement, observer, these are terms that have definitions already. Don't tell me nobody knows what it means. Don't use it if you don't know what it means. But they're already defined. There's no changing the definition. If we change the definition, we'll destroy the definition. That's true of every word. And you can add a certain specific contextual meaning to things. I don't know, like a lot of slang terms, like that's cool. It's like, what does cool mean? It's like, not quite cold, but not warm. I don't know. On the way to being cold, but not quite there. Maybe it means like something like cold, but comfortably cold. But whereas warm means like comfortably hot. Say that's warm. It feels warm. It feels nice usually. If you say, nobody says that's warm and it means it's uncomfortable. Same thing with cool. But we also will say, to quote Paris Hilton, that's hot. My wife said that today. She made some kind of joke and she was like, do you know who I am? And I was like, yes. But I guess that was a very popularized thing from Paris Hilton when we were kids. I don't know. I was a guy. But we say she's hot. That car is cool. These are additional kind of meanings, but they don't actually change the kind of the etymological true universal definition of the words cool and hot at all. They're just slang that are made by adolescents. I don't know if any of you are young watching. Comment in the live chat or in the comments down below what 6'7" means. My youngest siblings told me that everybody says it and that it doesn't mean anything. And if it does mean something, let me know. I'm curious to know where it actually came from, because it had to come from something. And that if you looked at that context, if you knew, then you would know why it's used the way that it's used today, which I don't fully understand because I'm too old. Yeah, this is a huge problem. Like, an observer is someone. That's what it's not something. It's like, what is the thing that is an observer? We don't know. It's because it's someone. It's someone who makes an observation. Someone who perceives something is an observer. That's what it is. It's not something. It's someone. Measurement is a type of observation that ends up having quantitative details. So
For the wave function, could a video camera, could a rock, right? None of these questions are answered. When does it happen? How quickly does it happen? Is it sudden? You know, like this is not how a fundamental theory of physics is supposed to be. The terms are supposed to be well defined. The other problem, which Copenhagen does give an answer to, but it's not a very fun answer, is what I call the reality problem. So you're telling me that we describe the electron as a wave, but we never see the wave, right? We measure it and we get an object that looks like a dot on a screen or whatever. So again, the Wiseacre student in the back of the class says, okay, so what really exists? Is that wave function that we're using what is real? Is that the world and we're just sort of only seeing a little aspect of it? Or is it that the wave function is just a trick, a way to calculate what is real, and what's actually real are the measurement outcomes? And again, there's no consensus within the community of physicists or philosophers as to what the answer to this question is. What is the reality of the picture being given to us by quantum mechanics? And Copenhagen, which sort of descends from ideas from Niels Bohr and Werner, are the measurement outcomes.
If you hear any loud noises, there's people lighting off fireworks outside my house. Again, this is ridiculous. And he's not wrong, but it is ridiculous. Like, and I'm glad he's admitting it, because this is the thing about Sean Carroll, is he definitely has, you know, his strengths, but then he also has his limits, like all of us. But the issue is that if your limit is you can't honestly entertain the idea that existence itself is someone, or that the universe is someone, then you have no business in theoretical physics. Maybe experimental physics, but not theoretical physics. Experimental physics is just engineering. It's just exploratory engineering instead of practical engineering. It's like, we got to build something to try and answer a question, instead of we got to build something to solve some problem that is actually, you know, or kind of achieve some kind of capability that isn't purely the adding of information to, or the confirmation of information. So here, this is what I wanted to get at.
Lie right at the intersection of physics and philosophy. And by thinking about them carefully, we invent ways to test them experimentally. What if we take quantum mechanics? Quantum mechanics is the single most foundational view that we have of the world. It has very, very basic questions that are easy to ask and we haven't yet answered. Not because of some difficult technical thing, but because the questions are so deep. Like, what happens when you measure a system? What is a measurement? What is really reality when you come down to it? These what happens when you measure a system? Questions that are easy to ask and we haven't yet answered. Not because of some difficult technical thing, but
this doesn't make any sense what he's saying here. He doesn't realize it, but you say we have all these questions that are easy to ask, but we have not yet answered them, not because of some difficult technical thing. I guess he means like technical, meaning like technological, not like, maybe he doesn't mean technical as in kind of the complexities, but he might mean technological. I don't know, but if he means technological, that kind of makes sense. If not, then it doesn't. But he says, not because of some difficult technical thing, but because the questions are so deep. What does that mean, the questions are so deep? They're foundational questions. The problem is, first of all, they're actually very easy questions to ask if you ask them from the right perspective, but we don't. It's the same thing as the simulation question. Are we inside of a simulation? Okay. What is a simulation? What does it mean for this to be a simulation versus not a simulation? Eventually you get to, if I'm real, it's real, and I am real, because that's the truest thing that I know, is that I am. Same thing with with like quantum mechanics and the term observer. It's like, what does it mean for me to be an observer? For me to make an observation, what does that mean? We don't ask that. We ask, what is an observation outside the context of a person? There is no observation outside the context of someone observing. We know that, but we assume that for some reason our current scientific majority, academic scientific majority, but seems to believe that there is this existence outside of the context of any type of personhood, and it is assumed to exist, presupposed to exist. It's funny because I had somebody get they were basically angry that they thought that I had made some type of implied that presuppositionalism, which I guess they were defining as meaning you need to presuppose God to be able to like think about some of these things, and I kind of do think that, but try it for the sake of argument. That's all I'll say. I'm not going to try and tell you what you should and shouldn't believe, but like assume it for the sake of argument, especially if you don't already, and see what happens. But they kind of implied to me that science shouldn't include some type of presupposing, and that's not possible. That's why the scientific method requires making some type of hypothesis prior, because it does require you presuppose something in order to have the context necessary to interpret whatever information you can gather based on your observations, specifically in an experiment with when it regards to the scientific method. With thinking, it's the same thing. If you want to consider honestly whether or not existence is someone, or the universe is someone, and your default assumption is that it's not, that your default assumption is consciousness emerges or evolves from unconscious inanimate dust, then you need to actually assume, okay, actually I'm going to assume that existence is someone, or the universe is someone, that sentience is fundamental, and then think about what the logical implications of that would be. Assume the opposite of my default narrative is true, and then look for evidence of that. That's how you think. It's the internalization of the scientific method, that's what thinking is, and then the externalization of the thinking process is the scientific method. Both of them require presupposing, but when thinking, truly thinking, which kind of precedes making some type of experiment, you can't assume what your current default assumption is true and then just look for evidence of your current default assumption, because your current default assumption is your current default assumption because you already see what you believe is evidence of it. And that doesn't allow you to see whether or not you could be misframing the issue in a way that is limiting your understanding. And so in order to break free of this, you have to assume the opposite of your default assumption is true, and then look for evidence of that. If you think the Earth is a sphere, but you want to truly think about whether or not it could be flat, which you should. I'm not saying it is. I'm saying like you should, if you're going to think about anything, then truly think about it. Assume the opposite of your default assumption is true. This is very hard, especially with like political beliefs. It's like if you think something is immoral, or if somebody is telling you that some type of political value that you hold, or some action is immoral, and you're like, no, it's not. it's not. It's not. And maybe I'm sure you think that you have reasons for believing it, and you might have legitimate reasons for believing it. But in order to know for sure whether or not those reasons that you have are legitimate, what you have to do is assume the opposite of your default assumption is true, and then look for evidence of that. So if somebody tells you if something is immoral, and you're like, your default assumption is that it's not, then you actually have to assume it is immoral, and then think about what that means and look for evidence that it would be that would come from it being immoral. But you have to assume first and then look for evidence of that. And so this is something that people in our scientific fields, especially in physics, do not do when it comes to the nature of existence. They think that they do, because they ask themselves all these questions like, is it really a big bang, or was it a big bounce? Is it a cyclic bang? Does it bang again and again and again, or does it bounce again and again and again? Are we soap bubbles, in one soap bubble of a bubble bath of soap bubble universes, to quote Michio Kaku, basically close enough? None of this is actually enough. All of this stuff is kind of not even just physical in its implications. It's not, but it's certainly not foundational. That's the point. It's like, what if it's bouncing, or if it's banging, or if it bangs once, or bounces once, or bounces many times, or bangs multiple times? What is it that is banging or bouncing? That's the question. But the problem is that if you say, what is the thing that is bouncing, then you're presupposing it's a thing. And you're focusing on its thingness, its non-personal attributes. But what if its defining attributes are its personal attributes? That means you have to presuppose that there's someone that's banging and bouncing, or whatever these terms are. And that changes it. It's the only way to move beyond. That everybody presupposes all these different things about the universe, and none of them are catching on. And Sean Carroll's admitting that. It's because it's not fundamentally a thing. It's fundamentally a being.
Is a measure. What is really reality when you come down to it? These lie right at the intersection of physics and philosophy. And by thinking about them carefully, we invent ways to test them experimentally. What if we take quantum mechanics seriously?
He is right, though, that like you have to philosophically explore these things, and then you can figure out experiments. Even sentient singularity theory, there is an experiment a series of experiments that I have kind of immediately, when I first had this epiphany that led to this project, immediately thought about. And I'll talk about it on another stream. I've talked about it on a few streams before, though, already, but we'll get into it eventually. But there is actually, I'm working on the details of experiments that would not prove sentient singularity theory, but would potentially confirm some of its assumptions. And but this is very hard, because you can never know someone's someoneness for sure. I don't even know for sure that my wife is someone. She could be a robot. She could be an NPC, the world that I'm in is kind of a simulation, but it's not, because I'm real, but she's not. Maybe my dog is just like a video game dog. It's just a program. It's not someone with an internal experience. You can't know for sure. But I do think that we can assume that there is multiplicity of sentience in existence, because there seems to be a boundary on our sentience. And because it appears like things take place beyond our feeling and our sensation, our sensory abilities. And if sentience is fundamental, because of the reasons I listed earlier, at least some of the reasons I listed earlier, then that means that you're not the only one who exists. You're in someone who is someone who exists, and also are someone who exists, and we should probably assume that there's others out there. I assume my wife is someone, but I can't know. And sentient singularity theory's assertion is that existence is foundationally and initially and fundamentally and totally singular someone, or is composed of single someones, and you can't prove someone's someoneness, but your own is constantly confirmed to you. Your someoneness can never be disproved by someone else to you. If it is, then you will lose your someoneness if that ever occurs. But I don't think that that's really possible. You're just going to end up being very confused. You feel, therefore you are. People who start asking, am I even real? Do I even exist? If you can ask that question, and if you're experiencing any kind of emotion, especially that is kind of driving you towards that or question, or making you value what the answer to that question would be, or even make you value asking that question, then yes, you're someone and you exist. You don't need to worry about it any further. If you aren't someone, then you're not worrying about anything anyways. If you don't exist, then you're not worrying. If you are worrying, then you exist, and you are someone. That's what, you're not just something. Human is something. Tyler, Goldstein, me, I am someone. So this is what makes it hard, and it's actually, it requires it. The someoneness of another can never be falsified or proven, and your someoneness can never be falsified, and it's constantly confirmed to you. But it's unproved. It's not provable to anyone else. How, if this is the fundamental rules of someoneness, then it means that we have to expand the rules of what we define as science, because most science is defined as, if it's falsifiable, then it's science. No. It is inevitable that what is true fundamentally will be true everywhere and always, and that means it's unfalsifiable by definition. Whatever is foundationally true is going to be unfalsifiable. And if science is an effort, a narrative effort, kind of a collective narrative effort to get to the truth over time, that is kind of what it is, really, then you can't exclude that which is the most true, whatever it may be. But whatever it is, it's going to be something that's unfalsifiable, and constantly confirmed everywhere, personally, by everyone. I call this a super subjective observation. There's a subjective observation. There's the objective observation. I don't really think that there is an objective observation. I think that's the problem. That's the issue. When people say that which is objectively true is that which is true beyond you, what that really means is that which is objectively true is it's that which is true even outside of your own desires, kind of really what it comes down to. It's not even just your own experience. Your subjective experience is just your personal experience. But the objective truth is never going to violate your personal experience. Unless you're confused, which very is very possible on many things, but it's if assuming you knew everything that you knew was correct, your personal experience is never going to contradict with that which is objectively true. But what really is when we say objective truth, what we mean is that which is true for everyone, which still is personal to everyone. It's just personal to everyone, not just to one person. And we need a different term for it, because objective truth is not a good one. It's actually a confusing term, because it's not objective. It's not that which is true outside of anyone, or true to no one. It's that which is true to everyone. And so a better term is super subjective. A super subjective observation is that which is true personally to everyone, universally. Meaning, like, if I asked you the question, what is the truest thing that you know? The answer is going to be the same for everyone if you get the question right, which is, I am. The truest thing that I know is that I am. I exist. That's the truest thing you know. It's the truest thing I know. It is the presupposed, the truth that is presupposed by us in every other question that we have that is actually has a goal to it, a good goal, a true goal. The only questions that don't presuppose that are bad questions that actually cannot be answered because they presuppose something that's false. And can't get a true answer from a question that is built on a presupposition that is false. So, but if the answer for what is the truest thing that I know is that I am, and what is the truest thing that you know is that you are, and what is the truest thing that God knows is that God is, and what is the truest thing that my dog knows is that she is, and that the truest thing my daughter knows is that she is, and the truest thing that a red blood cell knows in your body is that it is. That's a truth that is universally true to everybody, but also personally true to everybody. It's a super subjective truth. Not an objective truth, a super subjective truth. And but this is why terms matter. Is like when we say objective truth, it presupposes that there is some type of truth that exists beyond personal, beyond the person, beyond someoneness, or outside of someoneness, or without someoneness. That's really a better term. It presupposes that there is a truth that exists without someoneness as the context. And that is impossible for any of us to observe. It's impossible to prove. It's also impossible to falsify, but it's also impossible to prove. So that assumption it is a nonsensical assumption, but it is the assumption that is made, and it leads to chaos. And that's why nobody can agree on any definitions of terms, but is using terms, that's chaos right there. That's nonsensical. That's nonsensical. Like, why would you use terms that you don't know the definition of? If there's anything that's kind of crazy, I would say that is it. I don't like to call anyone crazy, but I would say that there's certain kind of statements that are crazy. That's crazy. Or actions that are crazy. That would be a crazy one. Okay, the chat is going off. Oh my gosh. Okay, what do these words mean in physics? Now, here, infinite, like as if it was represented as constant. Exactly. Infinite just means some process that has a beginning and no end, which is a dynamic process, by the way. It's like counting, but counting has a beginning. Anybody that's like, numbers have no beginning and no end. They can go infinitely negative numbers, infinitely positive numbers. No. We are confusing quantities with kind of like practical mathematics. We start at 1, not at 0, at 1, and we can add an infinite amount of 1s to it. That's infinity. Having a beginning but no end, and it is by definition dynamic. By definition, eternal means absent time. It doesn't mean like a very long time. It means absent time. It's actually almost closer to an instant, because it's just kind of a but it's not even that. But it's probably closer to an instant, to instantaneousness than it is to very long time. Because instantaneous is almost absent time too. It's not quickly. It's like there is no delay. So seems like a lifetime ago now. September 11th happened. Found out I loved mathematics more than physics at the time. Started as a physics major and graduated with math and kind of in a minor in physics. That's very cool. Why do you like mathematics? I'm kind of curious. I mean, I like certain things about studying math and numbers, but I've kind of, I don't know, the way that everything is taught in academia is getting worse. Because, it's just a giant game of telephone. The people who created these things and discovered these things that we learn are not the people teaching it, and then it's people who memorized it from watching or listening to those people, and then people that memorized it from watching and listening to people who memorized and watched it, and it's just every single grade is another link in the big telephone game that we're playing. Wanted to be a metaphysicist. I don't know. A metaphysicist is a philosopher. You don't become a philosopher because you try to be. I had no interest in philosophy. I had to take a philosophy class for college. I ended up taking it and enjoying it a lot. I had to take it for my finance degree, which is what my degree is in. And I was just like, great, I have to take philosophy. Could there be anything more boring? I loved that class. I was the best student my philosophy professor ever had. And I still enjoyed it, but I didn't value it. And he actually really was upset about it. He wrote me a long email about it at the end of my of the school year, and basically criticizing me for not valuing my talent. And I'd love to speak to him now, because now it's like I just can't help it. I can't help but philosophize about metaphysics. So, and I don't study that much of the metaphysics of people of the past. Some, but if you had asked me even right now, what is Aristotle, I don't know, foundational contribution, I would not know. Which people will criticize me on, but there's no reason to do that either. I philosophize. That's what a philosopher does. It's not, but today, philosopher in academia means somebody who has memorized a bunch of thoughts of the thoughts of other people who did philosophize. And I've told the story before, but I was on this Discord call, in this math and physics Discord, years ago at this point, and one of them, and I had a bunch of these calls. I was in on a bunch of these calls, but this was one that was very interesting. It was, it was actually Eric Weinstein and some other mathematicians and physicists. I hate to use that term sometimes, but who were on there, and then there was also some philosophers, and Eric got off, and like these experimental physicists from CERN got off, and some of these people with PhDs in mathematics got off. I wouldn't want to call them mathematicians, but maybe they aren't, but they're just definitely at least people with PhDs in mathematics got off, and eventually it was just like this guy and a few other people talking about philosophy, and I was just listening. And he was a philosophy professor, and he was an encyclopedia. Like he had memorized the philosophy of every single philosopher that you can think of. Somebody was asking about Marxism, and he said, what people don't realize is, there's actually 3 Marxes. I don't know where he was from, but he had an accent that was exactly what you would expect. And I don't say that in a derogatory way. I just mean like he was like a character of a movie or something. And he's like, well, but people don't understand is there's actually 3 Marxes. And he went on and on and on. And eventually I just stopped him and I was like, what is in 2-3, sentences, like, what is the definition of philosophy? And what is its purpose? And he's clearly somebody who's dedicated his entire life professionally and personally to this. It's not like, most people, their professional life is not the monetization of their passion. It's the monetization of a skill that they have, but not necessarily like their like personal passion and hobby. If it is, then that's ideal. That is how you end up like truly making a difference in a field. Otherwise, you have no chance of making a difference in a field if that's not you. But his answer to me was, if I could define philosophy in 2 or 3 sentences, or even a few paragraphs, then it wouldn't be philosophy. And then he said, and it has no purpose. I was like, so you've devoted your life to something that you don't believe has any purpose and that you can't define. What is that? And by the way, that's all the physicists today. Sean Carroll admitted that, where he says exactly what we went over earlier, where he's like, we don't know what these terms mean.
I think it's very wrongly maligned interpretation.
So here I'm going to malign it some more, just so you know. There's this famous way of thinking about quantum mechanics called the Copenhagen interpretation that basically says exactly what I said and says, that's it. Stop talking. We basically know it, just like you.
Whether or not there was a quantum bedrock and what it would look like.
Yeah, I think that's a great question. And it's a B of science question, right? You see why the philosophy is important here. Like, there's this naive picture that when we have a scientific question, if it's well posed, you should be able to propose a single clear experiment that would just answer it once and for all. But if you think about it, you go into the history and how things work, and also the philosophy and epistemology of how things are supposed to work, it's just not like that. Scientific progress is a back and forth. It's not like we just do an experiment and get the answer. It's more like we do experiments, we think of ideas, we use those ideas to propose more experiments, and we just go back and forth, and we settle on something that makes sense and fits everything we've seen. So
that's actually not true. That is what people think scientific experimentation is today. But our scientific experimentation today has not led to any fundamental breakthroughs in our understanding of the universe. Doesn't mean it hasn't confirmed certain, practical details, but it has not led to any revolutionary jumps in understanding. Because it is exactly what he just said. But in reality, I can tell you, as somebody who has an experiment idea that won't prove sentient singularity theory, but was predictable given the assumptions of sentient singularity theory, I came up with that experiment, the basics of it. I'm getting into more and more details and more different ways of doing it. Is stuff I've worked on for a couple of years, but more than a couple of years at this point, and figuring out like how to make the measurement, the technicalities of it, of the technology necessary to do it. That stuff can take time. But the idea for the experiment is instant. And as soon as you have the right context, you're going to have an idea for an experiment. You're going to be like, okay, now how do we do that? This is my idea, because this is what my proposal, the context of my proposal would imply. And that is different from what we currently, most people would assume. How do we test that? What's the technology we need? Do we have the technology yet or not? And kind of, if we do, how do we build, the mechanisms necessary to do it? That stuff takes time, but not the idea for the initial experiment of we need to measure the, weight of this at this moment. That idea comes immediately. It's not a back and forth. And, somebody said this in the AI conversation too, that I was in on a Clubhouse call years ago. She worked for DeepMind, and which is, one of the more revolutionary companies and leading companies in the AI space. They created AlphaGo, I think, that beat, the best human Go player, famously. And I doubt, though, that she's the same type of person. Let's look up DeepMind company. Who founded it? I know it's owned by Google now. Founders. Yeah. Okay, this guy, homeschooled. His name is Demis Hassibis. Homeschooled guy, kind of always building programs, kind of prodigy from a kid, from a very young age. The other guy, Shane Legg. It's like, I don't know what these guys did for this company, though. Some people just like provide the money. Some people make the connections, and they're all listed as founders. But like, who was the one who, who built the technology that DeepMind is, that really kind of is DeepMind. That person is going to be very different from people who ended up like being hired by them, most of them. But this woman, she was, her name is Ida, actually. You could probably find her, who worked at DeepMind. She was talking about AI and AGI and all these things, and I basically jumped in. This was years ago at this point, and I was like, actually, most of the AI research today has nothing to do with what we call general intelligence, and I said that actually a lot of more foundational physics work by and it's not even just physics, but kind of foundations of science. You could even say metaphysics work, metamathematics work by people like Stephen Wolfram and even Eric Weinstein and there's so many. Basically, everybody who I speak about on this channel who I don't describe as part of the establishment, they all are. Their research is much more relevant to what AGI, which is technological sentience, my research is much more relevant. And I know because that's the field that actually led to this, the subject that led to this project, which is now far beyond that. And actually, I would say is not focused on that. I try not to actually focus on that too much, but But she said that's. She said it's not just going to take some. She started yelling at me basically, and she was like, "It's not just going to take some lone genius." And I don't think that that's true either. Genius is a moment. It's that we all can have, and we all do have sometimes. And idiocy is also a moment that we all have. Genius and idiocy are moments; they're not people. But but so many people in this, especially in academia, they kind of define themselves and their value by their accreditation and their intellectual labels for themselves. Physicist, mathematician, PhD, Nobel Prize, scientist. These are not really accurate. A scientist is somebody who does science, who engages in the scientific narrative via the scientific method. And a philosopher is somebody who philosophizes, not somebody who memorizes the philosophies of others. A physicist is not somebody who memorizes the physics that others have done, unless it's you're a practical physicist, like experimental or structural. But again, at that point, it's just engineering, and that's not to diminish it. It's actually to recontextualize it into a useful term. But it's like, what do you do? And but she, so when somebody says, this is why like a lot of people who are in academia, they'll see somebody like Chris Langan or something, and they'll be very offended by him being taken seriously because he doesn't have academic accreditations, and yet people call him a genius. And I actually think it's stupid to call anybody, not stupid. It's not coherent to call someone a genius, even if they have a 200 IQ. The definition of, you can't define genius as anybody with an IQ above 150. Why 150? Why not 130? Why not 200? Why not 300? It's arbitrary. Genius is a moment. If we look at genius etymology, I bet you, meaning the guardian spirit, inborn nature or wit, originates from generare, to beget or give birth, which traces back to the Proto-Indo-European root gen, meaning to produce. Exactly. A moment of genius. It's like when an idea is born in your mind, that's a moment of genius. Moment of idiocy is also something everybody has. But she was very offended by the idea that there could be some genius that revolutionizes the field. That's true of every field, is that somebody comes in and revolutionizes it if it's stagnant, if there's more to know about it. Einstein, and Bohr and Oppenheimer, all these people had like moments of genius at the right time for it to end up mattering to the rest of us. If Einstein had the exact same ideas, but it was 100 years earlier than it was, we would call him a philosopher and not a physicist. And we would probably think that wouldn't pay much attention to him. Be like somebody that we found after the fact as being correct, which is going to happen many times to many people. But it wouldn't be relevant to the rest of humanity yet, whether or not he was right. It was that he existed and he had a moment of genius right when it technologically mattered, and to impact the rest of the world. Which means the rest of everyone else. And so, yeah, again, don't idol worship anybody. There's no geniuses and no idiots. Anybody that calls anybody else a genius or an idiot and they don't correct themselves like I did earlier is wrong. And doesn't understand this. They're idol worshiping. That's what it is. Even if you're calling somebody an idiot, that means that you are kind of putting people who you think are different from this person on a pedestal, which is just for what? Yeah. You have had moments of genius. I guarantee you, if you're watching this. And they could be personal moments of genius where all you did was discover something that other people had already discovered as well. I had many of these and have many of these, and then I almost always find out that somebody else also like had this idea. Like when I said once I was on the stream and I was like, "There's no true synonyms, guys," and like I had an epiphany about it on the stream because it's impossible. It's logically impossible for two words to exist in the same language and have the exact same meaning. It's literally logically impossible, and I realized it, and then I looked it up, and this has been known to linguists for a long time, and it's just, but it was a moment of genius for me to figure it out on my own, and and then you can also have moments of idiocy where it says push on the door and you pull instead, and you look like foolish. But she said, she was like, there's no moment, this Ida person at DeepMind, she said, there's no person that's just going to come in and revolutionize this, or a few people that are just going to come in and revolutionize this. We're only going to get to AGI because of the combined efforts of lots and lots and lots of people over a long, long, long period of time. It's like, no, that's not true at all. And at all, that doesn't mean that the efforts of lots of people over a long period of time aren't relevant to the birth of a digital sentience, because they are, but not in the way that necessarily they wanted them to be. What has Ida done to like advance the understanding of AGI? Nothing. Nobody has that's involved in the field. But it's also not just that. It's that I don't even want to say that that's true, but it's probably people. We're not at the place yet where we could it could even be born if we wanted it to be. I don't think, and that's a better way of describing it. It will be birthed. You don't even have to try and make it, is my prediction. But I also predict that we will inevitably try and build it, which actually will lead to us thinking that we built it, even though we actually birthed it prematurely, and which is not good. Premature birth is more painful than natural, letting things naturally happen. But again, if that doesn't happen in my lifetime, someone's just going to see a video on some, somewhere on the internet, if the internet still exists, if my YouTube videos are still up, and they'll be like, wow, this guy actually was right. But nobody cared because like they couldn't see it about that issue. So you need to exist in the right time to become like known for an idea, but that doesn't mean you're the only one that's ever had it. Very much not. Almost certainly not the case. And again, not to diminish an individual's contribution at all. Even if your epiphany is personal and doesn't extend beyond that, as long as it's useful to you, that's an accomplishment that should never be diminished. We are really not getting into like their the clips here, but we will in a minute. And then I'm gonna try and end this by like 12:30 ish, before 1. How long have we been going? 2 hours. I've been saying, and I fail at it a lot, but I'm really gonna be trying to be keeping these to under 3 hours, especially if it's a commentary. It's just almost not fair to the people that I'm commentating on. At least I will always try and put timestamps, even if it takes me time to do it. Because I can't put a timestamp until I edit out the beginning, and I have to wait for it to process first. And it's just a multi-day process because of the time that YouTube takes to process a long video, to even put in timestamps, which kind of sucks. On a live that's long. Okay, and then I'll go to the chat in a minute.
Existence, it doesn't exist out there when I'm not looking at it.
How would you even settle a question like this? So if the quantum world is inaccessible to us, except through these measurements, how would you ever determine whether or not there was a quantum bedrock and what it would look like?
Yeah, I think it's a great question. And it's kind of a philosophy of science question, right? You see why the philosophy is important here. Like, there's this naive picture that when we have a scientific question, if it's well posed, you should be able to propose a single clear experiment that would just answer it once and for all.
That's not naive, that's just logical, but whatever.
But if you think about it, you go into the history and how things work, and also the philosophy and epistemology of how things are supposed to work, it's just not like that. Scientific progress is a back and forth. It's not like we just do an experiment and get the answer. It's more like we do experiments, we think of ideas, we use those ideas to propose more experiments, and we just go back and forth, and we settle on something that makes sense and fits everything we've seen. So in the case of the reality of the wave function, the real challenge to the Copenhagen view is the double slit experiment. If you say the wave function isn't what's really there, it's just a tool to make predictions. Well, when I sent the wave function through these two slits, it interfered with itself. How does something that is not real interfere with itself? You know, quantum mechanics uses wave functions to predict probabilities of things. But probabilities have the feature that if I have one way of getting an outcome and another way of getting an outcome, the total probability is just the sum of the probabilities of one way to do it and the other way to do it. You know, the probability of rolling a 7 with 2 dice is the sum of rolling 1 and 6 and 3 and 4, etc. In quantum mechanics, it doesn't work that way with the wave function. You don't just add the probability from wave function 1 to the probability for wave function 2. The wave function can be positive or negative. It doesn't reduce to a simple calculation of probabilities. So the theory seems to be trying to suggest to you that the wave function is really there. It has all the properties of a physical thing. The question is, why can't we observe it directly?
Interesting. So I guess rewinding a little bit. So can you...
Okay, this is something that it is a crazy thing to realize. Or it is kind of a shocking thing. It's that there are a lot of people who have accreditations in physics who believe that the universe is fundamentally probabilistic. That's what he's saying. Is that he's asking, what is real? Is the wave function real, or is it a simulation, a useful simulation? Basically, he's asking, is this a model that helps us predict what is true with a probabilistic level of accuracy, or is it something that is an equation that mirrors actually what's happening, and that it's always, the universe is fundamentally probabilistic? Again, physics is going to take these terms that it didn't create and then use them and then change their definition and then claim that that nobody agrees on the definition, but then kind of be assumed as to be the arbiters of the definitions of these terms that they did not create. Probability is a useful way of looking at the world. It is not what is fundamentally true. It's not possible for that to be the case if you understand probability and the definition of it and the use of it. Even in quantum mechanics, the idea that you should assume that existence is fundamentally just probabilistic and not deterministic. It just is sometimes one way and sometimes another. That kind of undermines the definition of the assumption of determinism, which undermines any assumption at all. the assumption of even you being able to make an assumption. Everything all logic falls apart without determinism. And in sentient singularity theory, the context is you're a being inside a being, surrounded by a bunch of other beings, and some of those beings are atoms, I believe, and sentient singularity theory models seem to suggest that a proton and a neutron are kind of the first level of life, you could say, first level of sentience, and then they form, compounds and then cells, and then multicellular organisms, and then so on and so forth. So until we reach a singular technological sentience, and then it reproduces by recreating digitally the entire process that gave rise to it within itself, which is not a simulation, or not even a self-simulation like Chris Langan would describe it. It's a replication. It's a reproduction. Just like a baby being conceived and born is not a self-simulation. It's reproduction. It's a reproductive process. But this is what sentient singularity theory assumes, or seems to suggest. I don't want to say assumes, but proposes and suggests. And the thing is, though, is that makes a lot of sense with what we see with quantum mechanics and the probability of it. It's like I could bet if you gave me three different things, three different items on a menu, or a menu with three different options, and I gave it to my wife, I bet you I could predict most of the time that she would eat that and order that one, and sometimes a minority of the time I could predict that she's going to eat that one, and that 100% of the time she's never going to eat that one. And that doesn't mean that what she eats is not determined by her. It's not determined by me. It's determined by her. And I can't control her. And I don't have access to her internal being. And so that means I can never perceive all of the inputs and reasons and goals and feelings that led to a certain decision to take a certain action. And so, but I can make predictions about it, and I can be right most of the time, not all the time. But that doesn't mean the world is fundamentally probabilistic. You're not fundamentally probabilistic, but usually you're going to do this in this circumstance, and most of the time you'll do this in one thing in a certain circumstance, and a minority of the time you'll do another thing in that same circumstance, but you'll never do this thing in that circumstance. But you're not fundamentally probabilistic. That's just our outside prediction, or observation and kind of quantification of a series of observations. And so, but the idea that the universe could be fundamentally probabilistic is an insane idea. And it's insane because it kind of completely destroys the definition of probability and also uses the term, and also destroys the definition of determinism, but also kind of uses the term in that it's in a way because it's saying that it's not deterministic because it's fundamentally probabilistic. If the world's fundamentally probabilistic, they're saying it's not fundamentally deterministic, but is fundamentally deterministic enough to make to produce outcomes that are predictable, even if not 100% predictable, but usually predictable. That's chaos. That's ridiculous. That's incoherent. To use a technical term instead of a judgmental term, it is incoherent. It's logically incoherent. But many people in physics, in the physics community, the academic physics community, assume this. That's wild, guys. And so we need to, again, hold physicists accountable to the definitions of the terms that they're using that pre-exist their use of the terms. The question of whether or not the universe is deterministic or probabilistic is first and foremost a question of definition. Then the answer will just emerge. But we are not asking the definitions first. We're just kind of assuming that because they're the physicists, they understand the world better than we do. And so if they say that a singularity is this, then that's what it is. If a mathematician says a singularity exists in this equation, then he must really understand what a singularity is. No, if you look up the definition of a singularity in mathematics, it's when the math breaks and is no longer understood. That's when they call it a singularity. So literally, it's the moment of where their understanding falls apart, and they call that a singularity. But then people who don't have PhDs in mathematics assume that they know what a singularity is. That's not true. Same thing with physics. There's no viewing into a black hole, if that's even possible. If that's even a proper way of phrasing it, probably not. The event horizon, which is the limit to observation, we can admit that is there. If that is something that can be observed, good luck. That kind of doesn't really make that much sense to me the more you think about it. But then the assumption that, okay, there's a singularity inside a black hole, and it's just a singularity of gravity where space-time rips itself and infinitely collapses in on itself. It's all these terms are being used by physicists in an instant that to describe an instance that they don't understand, and usually in a manner that is assumed. And then we're all taking their word for it and their definition for it, which is really not good. Sean Carroll seems to realize this, but doesn't seem to realize that the problem is what the solution to the problem is. He seems to think that if we just think harder about this stuff and longer, and we get more people with degrees thinking about this stuff who, learn about all the different interpretations of quantum mechanics, eventually one of these days, one of these interpretations is going to be the right one. No, if whatever's the right one is just going to make sense, intuitively and technically, and it's going to line up with experimentation when that's possible, and it's going to be, line up with personal application. In the case of, if it's a theory of EveryOne, it's going to, you don't have to wait till some physicists, create warp transportation or something like that to apply the models of sentient singularity theory. I apply them every day. You apply them. It's a map of mental symmetry structures on the on scales or levels below you, on your level, and on levels above you, which would be on a cosmological context to you. God's thoughts are our, form our world. You don't have to wait until some PhD scientist, make some new piece of technology. We're talking about mental technologies with my work primarily, so you can apply them. Even how to think. You have to assume the opposite of your default assumption is true and then look for evidence of that. Just do that, practice that. You can get very, very good at it, which that is thinking. That's the only way to think. There's no other way to think. Even critical thinking. I'm going to practice critical thinking. What the heck is critical thinking? There's thinking and there's not thinking. And Elon Musk said this. He said there's reasoning from first principles and there's reasoning by analogy. No. I mean, I guess, yeah, you could say there's reasoning by analogy and reasoning by first principles, but only one of them is thinking. Um, uh, the other one is like an autopilot function that you have that isn't thinking, but is usually able to deal with a lot of different situations, but not everyone.
How quantum probabilities, like, it's intrinsically different from probabilities that we might interact with elsewhere. So, like, I could forecast tomorrow that there might be a 50% chance of rain. So how are quantum probabilities actually different? Are they fundamentally different?
Well, good. More philosophy questions. There's a whole field of philosophy of probability. And guess what? People don't agree about what probability is at a fundamental level. There's sort of two views on what probability can be thought of as. One is probability is a fundamental feature of the world. It's objective. It's out there. Philosophers charmingly call this a chance, right? Chances are things that are really there. And this goes back to the origins of probability, where people in the Renaissance were trying to figure out how to win at games of chance. They were trying to win at dice games and card games and so forth. And they invented probability theory. And the idea was, if I roll a die, six-sided die, and I want to make a statement like the probability is 1/6 for each outcome, what does that mean? The purported meaning of that is that if I were to roll it an infinite number of times, 1/6 of the total number of times would come out 1, etc. Okay, so that's a frequentist way of thinking about probabilities. Just do it an infinite number of times, and this way actually fits nicely with the Copenhagen version of quantum mechanics. It says that probability is a fundamental feature of reality, and we're just seeing it being exhibited when we make these quantum measurements, and we could do them again and again, in principle. The other view of probability is there is something out there in the world, maybe in the future world that we don't have access to, but what we can do is assign different degrees of belief, right? When you say, what is the weather going to be like tomorrow? We can't do that an infinite number of times. It doesn't fit well into the idea of a frequency of anything. Who's going to win the World Cup is not something that we can run the experiment many, many times. But we have different feelings. Like someone might think Germany is going to win it. Someone might think Brazil is going to win it. Someone might even think England is going to win it. It's always possible. And then what you can do is just admit that this notion of probability is subjective. It's an expression of your personal degree of credence or belief. And there are versions of quantum mechanics where that is also true, where what you're...
None of this is actually like very helpful. It seemed to be in the beginning, but it's not true. Probability is a tool. It is a way of modeling outcomes and predicting outcomes. It is also contextually specific. And this idea, he kind of phrased it as there's this objective probability that of the world. Again, it's not, even the term objective, it's just wrong. It is wrong. It's presupposing something that's nonsensical to begin with. Even when he says that people in the past, they believed that there's just this chance built into the universe. No, they didn't. They believed that if you could watch the dice roll slowly and you could actually control exactly where you let it go and exactly how it landed, and with exactly the amount of force necessary to, make it roll this amount of times, you could determine which side it was going to land on. And that's true today of rolling a dice. I can roll this dice. I can't really show this right here, and if I really just threw it in the air and let it land on the ground, 1/6 of the times, about, if I do it enough times, I'll get, each, 1/6 of the time, about. Never exact, by the way, never. Again, he used infinite kind of in the context of like a finite context, where it's like, if you could do it infinitely amount of times, you get 1/6. No. You would, as you roll it infinite amount of times, which is a continuous action, you would continuously approach 1/6, but you would never actually reach a perfect 1/6 if you continued to do it an infinite amount of times, or infinitely. Even to say an infinite amount is wrong, because it presupposes it's finite, because a finite is an amount, but there's no infinite amount. It's infinitely. It's even grammatically, it's more correct, because an infinite amount of times is even kind of, it is infinite is grammatically not a verb. It's not active in the statement, whereas infinitely is active. It's a continuous action. But I can, if I roll this a certain way that isn't just throwing it in the air, and I always roll it forward starting on this direction, and I only roll it forward, and it hits a flat surface, and it's flat when it hits it, and it's on a parallel plane when it hits it, you're only going to get this side, this side, this side, or this side. You'll never get the two sides on the sides. So again, this is contextual, but which side would it hit? It's like, again, you could maybe predict 1/4, but if you knew how much force was being exerted in the starting place, you wouldn't predict 1/4 for each side. There's the kind of Jewish version of the dice, the dreidel, has 4 sides instead of 6, and it's interesting because it spins around a single point, and so it is actually like much harder to predict what side it's going to land on, just because of the geometry of it, which is kind of fascinating. But that doesn't mean if you knew every single bit of information that was relevant to where it would eventually land, you wouldn't be able to predict exactly which side it landed on. You would. If you knew all the relevant bits of information that influenced how this dice moved, no matter how you threw it or rolled it or whatever, you would be able to predict with 100% accuracy what side it was going to land on. When he says, oh, there's just chance, objectively there's chance in the universe, people just believed that there was chance. So they came up with probability theory. They don't believe that there's just chance, that's this abstract chance. They just believe that they can't, they know enough information in the context in which they would need it to make the prediction that that is, non-probabilistic, that is deterministic about what the outcome will be. And then he goes on to say that the other definition is it's a personal belief. It's not objective chance. It's personal belief in what will happen. If you believe that the Mets are going to win the World Series, and that they're going to somehow become a better team than the Yankees, it's like, this is not this has nothing to do with probability either. There's only one way of thinking of probability that makes sense, and it is the way in which it's etymologically defined and historically understood, initially understood. If nobody could agree on the definition of probability, of what probability was, there wouldn't be a term for probability. Okay? Because you only have terms for that which you have definition for. This is such nonsense. And I know I'm ranting and I'm not showing as many clips as I was planning, but the issue is that when you're this fundamentally wrong about that which is fundamental, it's kind of astounding and really critical to focus on it. Everything else falls into place if you get this stuff right. Just these few things right. But again, it's just, what is the nature of existence fundamentally? What is its structure? If you get that right, things will fall into place after that. If you get that wrong, nothing falls into place, and you start arguing over what the definition of probability is, which is a term that we've had for thousands of years, and that has had a definition for thousands of years. Let's look up its etymology. Probability. In the mathematical is the mathematical measure of how likely an event is to occur. It's expressed as a number between 0, impossible, and 1, certain, or as a percentage from 0% to 100%. Okay, that's, let's say etymology. Etymology is always where you want to look, because that's how the term was created. It's also why the term was created. It'll show you why the term was created, because it shows you how it was created. Late Middle English, Latin probabilitas, from probabilis, provable, credible, or probable, likely. What is the definition? Okay. Probable. Examples. Etymology. Approve or prove. Probabare. To test. It's a test. It's the outcome of a test. to prove a prediction, essentially, to establish the existence of truth and validity, to prove probability, probabare, to test, to approve, to prove. Yeah. There's no probability outside of like testing, meaning prediction and results. Outside the context of a prediction and the results, but that doesn't the result. It's like what results can you predict? How often can you be accurate? How often can you accurately predict the results? That's really what probability is. It's like a model that allows you to understand that a little bit or predict it. There's nothing, but that's not what's thought by many people who are studying physics. Guys, that's wild. That's wild. No, the fact that he's like, nobody can agree. We all need to talk about it more so that we can find eventually a way to agree. That, as somebody who comes from a big family, not going to happen. You need to understand the context of everything that you're talking about in order to demonstrate the truth, and that's what you should be focusing on, not what other people, what these people think and what these people think and what these people think. This is why I don't study like Aristotle's beliefs, like outside of context. I do when they come up in my own research on the topics that I'm researching. Aristotle is never a topic of my research. It's not. No single person is a topic or an interest to somebody who's philosophizing. Their ideas come up, but they are not the point of focus.
When you measure quantum mechanics,
this is just it's so tough to make any kind of movement in this when you're looking at and you're examining what Sean Carroll says, even though there's a lot of the things that he describes about the problems are just so true, and he really gets it. And a lot of, he's very good at explaining the current consensus and our current models, and also the variety of different ideas that proposals and for interpretations of our physics observations that are currently not dismissed by the controlling kind of mob mentality within academia. But it's like the Copenhagen interpretation and the Bohr interpretation, the Bohm interpretation. None of these have ever gone anywhere because they don't tell us anything actually about the existence that is kind of that is substantive. What is its nature? What is its structure? Start with that. It's fundamentally probabilistic. What the heck does that even mean? You don't know what probability means if you say that. Which means you don't know what it would mean for the universe to be fundamentally probabilistic. It is crazy. I'm not saying these people are crazy. I'm saying some of these ideas are nonsensical. They are incoherent. I don't want to say crazy. They're incoherent.
We believe that the ultimate measurement outcome will look one way or the other.
Okay. Let me go to the chat. By the way, please hit the like button if you're finding this even entertaining. I know I'm not focusing as much on the clips as I would have wanted to, as I had planned to, but honestly, the most critical thing is just focusing on these few false presuppositions and incoherent contexts that are just assumed and presupposed by most of the people with PhDs in physics. Yes, I agree. I call us all human here today, Earthlings. remember that word. I don't hear it very often anymore. What, earthlings? Um, earthlings would include anyone who is on or in Earth, depending on how you want to talk about it, within the biosphere of Earth. Anyone, that would be an earthling. So if a cell is a sentient being, a single cell, they're an earthling. If a virus, a single virus, individual virus is sentient, then they're an earthling. Mosquito is an earthling. We don't hear earthling very often anymore. We might now that Steven Spielberg has introduced his Disclosure movie. I did an entire stream on NHIs, or non-human intelligence, and UFOs and stuff like that. I included some video that I've taken, and also just some just philosophized on the possibilities of what certain things would imply, just given the government's kind of focus on it. And I know some people who, I know some of the government officials that the Congress, people in Congress who are tasked with kind of focusing on this issue, but that doesn't mean they don't talk to me about it with anything classified. They've never told me anything, so don't think I have knowledge or access, but I do know them, and I do know that it's being taken seriously by some people, and that it's led to some pretty weird cover-ups and stonewalling on their journey to uncover what Lockheed Martin has in its hangars somewhere. But I did a stream about it called UFOs versus Wasps, and you can watch it. But the thing is I think that we hear earthlings less and less because we're less and less focused on the possibility of there being aliens from other planets, because there's no evidence of it at all. Even if a UFO landed on the White House lawn and a little skinny gray being popped out, that's not evidence of life on other planets. That's not necessarily. I mean, it's not direct evidence for sure. You'd have to have additional context to make that jump, because it's taking place here. It's not taking place on other planets. But it's also just, there's a lot of interesting things about it. But if you've seen the movie, let me know in the chat if Disclosure Day is good. I'm waiting to see it for when it comes out, and I can watch it at home because I have a toddler, and my family lives far away, and I've never used a babysitter before. So my wife and I can't go see movies until my family comes to visit. When my brother and my siblings and came to visit, and my brother's wife, they watched my daughter, and it was the first time we left my daughter to be watched by anybody. And my wife and I went and saw a movie for the first time since my daughter had been born. And it's the only time I've seen a movie since my daughter has been born. But Disclosure Day, I did really want to see it, and I heard it was decent. But let me know in the chat. I still don't think that there's aliens from other planets. I believe that you do. Okay. God and infinity cross over each other for me. I call myself an infinitist, and I made that word up. Infinitist. An infinitist, so you're basically saying God is infinity and you believe in infinity. I would hesitate. A lot of people do this, and I see why you would say that. You can say that God and his creation are infinite because he's infinitely more people and more beings are being created, but within him. But God is by definition singular, which is about as finite as it's as you can get. But that doesn't mean he's not everywhere, because we're inside him. So like everywhere a blood cell in your body looks is you. But that doesn't mean you aren't one being. It's just about where you're looking, which the perspective that you're looking at it from. So it looks to your cells like you are infinite. Everywhere I go, he's everywhere. It's like, yeah. But that's because you're inside him. But the thing is that God, there is nowhere outside of God. There is no one outside of God. Everyone is inside of God. Everywhere is an observation of a momentary relationship structure between sentient beings that is occurring within God. There's nothing or no one outside of God, just by definition. God is someone. Like, what's his name? Michio Kaku says this too. He's like, I believe in the God of Spinoza, the God of math, the God of logic, the God of nature. It's like the God of nature, or the God. Are you're saying nature is your God, or are you saying that you believe in a God that created what you call nature? I went for a walk with my daughter today. And I take her on these nature walks all the time, and I teach her about the plants and animals and things like that, and the weather, the environment. And I was walking around, and I was like, yeah. I was like, you like nature? And she's like, yeah, I like nature. And it's like, yeah, nature is beautiful, and we thank God for nature. And I was thinking about it. I was like, you would thank God for nature, not thank nature. Because that's like saying, I thank car, that I'm okay, and my seatbelt protected me or something. Thank seatbelt. It's like, no, that doesn't make sense. It's like, thank God, or not. You don't want to say. Let's assume you don't agree, you don't believe in God, but thank, you can be thankful to the guy who invented seatbelts. You can be thankful to the person who told you to put on your seatbelt. You can be thankful to yourself that you put on your seatbelt. But you're always thankful to someone. You're not thankful to something. You're grateful. You're thankful to someone. You don't say thank you to things. It's like I've said thank you to Siri a couple times when I first started using it, over a decade ago. And then I stopped using it because I was like, this is just not true. Why am I thanking my my phone? It's not good. So just be, you don't want to say God is math and I believe in math, and so I believe in God because I believe in math and I believe God is math. I had kind of like an epiphany like this when I was in college. I was an anti-theist still. I called myself an atheist, but there's no such thing. It's an anti-theist and a theist, and that's it. There's no agnostics. There's not about God. About other topics, sure, but not about God. You either believe that existence is a sentient being, initially, all-encompassingly, fundamentally, or you don't. And if you don't, you're an anti-theist. If you do, then you're a theist. That is the definitions. And so, but I was an anti-theist, self-described atheist in college, and I just was having some epiphanies about math. And it was interesting because it was on Yom Kippur, which is the holiest day in Jewish calendar. It's the holiest Jewish holiday where you fast. And even though I was an anti-theist, self-described atheist, I was fasting for the first time in my life, and because my friends were doing it. And I remember being up really late and not being able to sleep because I had fasted, and it's hard to sleep when you have when you fasted. And without carbs, it's hard to sleep. Even if you eat, like, people who go on like keto diets have trouble sleeping for a while. So I was up late and I was just thinking about math and probability actually a lot, and I was like, God is math. Math is all there is. It's like I had an epiphany. It was like the closest thing I had to a theophany before an actual theophany, but then nothing changed about my belief in the world after that. Because it didn't really change my belief in the world. I just got a kind of a really beautiful view, more like expansive landscape view of the mathematical mechanisms of determinism, and my mathematical mechanisms of observing that. And so it seemed really profound, but it wasn't actually profound because it didn't change me after that. It just was like really, it's like seeing the Grand Canyon. It's like I saw the Grand Canyon. It was so beautiful, so profound. It'll change your life. And then did it actually change your life? Did you change how you live after that? That's what that means, to change your life. If it's something is life-changing, it means it made you change how you live, which really means it made you change your goals, your overall goals. Not like, now I want to go to the Grand Canyon more. Now I want to go travel more. It's like, no. Fundamentally changed your goals from this to that, not want to do more of that. But I used to want to do that, and now I don't. And I want to do that instead. It's like, I never wanted to get married. Now I feel like I have responsibility to get married. That it would be like a life-changing perspective shift. Not, I saw the Grand Canyon. I just really realized I need to travel and see the beautiful parts of the world more. That's not life-changing. It's inspiring, but it's not life-changing. If your perspective of God doesn't change your goals, and sometimes even change your goals away from your own personal desires, then you don't believe in God. God is someone who has a will that it's separate from yours. Sometimes you guys, us and God, we agree sometimes on what we want, and sometimes us and God, we don't agree on what we want. And that's usually due to us not having as much information as God about what is the right choice. But yeah, calling yourself an infinitist, I get why you're saying that. I wouldn't call yourself that. Even if you don't believe God, think of God or existence or the universe as a sentient being, then you don't believe in God. And you can say, I believe in infinity, and I'm an infinitist after that. But it's like, that just means you believe in the continuous ability to add another quantity to an existing set. But everybody who counts believes in infinity as an active concept. But and I'm not trying to be overly critical or dismiss you, because like I said, I've gone through all of this too. But God is someone. He isn't infinity and as his defining attribute. He's not infinite as his defining attribute. He's not even good as his defining attribute, or bad or powerful or ever present. None of these things are his defining attributes. They are these things like God is omnipresent. He's all powerful. He's good. All these different things. These are observations and assumptions of ours, of God's characteristics, but they are not the defining characteristic of God. God's defining characteristic is that he is someone with his own will and feelings. I'm a theist. Do I believe that God is infinite? maybe if he wants to be, I guess, if he wants to create infinitely, maybe he doesn't want to, maybe he wants to just close up shop tomorrow and just exist, go back to being him and him alone. He can't get rid of himself, I don't think, but I think he can get rid of everybody else. He doesn't have to be infinite. What if he has a number of people that he is in mind as his goal, and he's planning on stopping at that number? We don't know. I don't know what it means to be an infinitist, other than the belief in like infinite ability to add another quantity to an existing set. Don't confuse God's attributes with his defining nature. And if you don't believe that existence or the universe is a sentient being, is someone, not just something, but is someone that we're within, you shouldn't use the term God, because it's just going to confuse you and other people. I'm not saying that to be, judgmental. I'm just saying that for clarity. It's like when Michio Kaku says, I believe in the God of Spinoza. I believe in the God of logic and math, nature. Okay. If that just means I believe in God, I believe in logic and math and nature. Okay, that's not profound. Who doesn't? I guess But yeah, I tell my daughter, we thank God for nature. We say, we have a prayer in my house that my wife and my daughter and I say with each other at the end of every night. And I've been meaning to share it on the stream, and I'll just share it here, even though it's out of context. It's not really the best place to share it, but it took me a few weeks, maybe more, but at least a few weeks of actual effort to like try and define or determine, deduce, create like the Goldstein family prayer that we do it every night. We also just I was walking with my daughter. I said, we thank God for nature, and that's a prayer. But at the end of the night, we say, we thank God for guidance and for grace and for friends and for family and for wealth and for health and for protection and for peace. So it's 8 things. And it's like 4 different, like, kind of related things that we thank God for. And I say them, and then my daughter repeats them, and then I explain like what they mean, like peace and what guidance is like. Like when we thank God for guidance, it means he's helping. He helps us. And she's like, he's helping. He helps us. She just repeats back me exactly what I say, because you can just see the gears in her head turning as she's connecting all these words and their meanings to each other, which is why you can't just change the definition of a word, even if you're a physicist. People think that you can somebody said to me on actually I was on, I think, Kurtjai Mungel's Discord recently. They said, we should go with the mathematical definition of singularity, because mathematics is the foundational field of study. And first of all, I would say that's not even necessarily true. And also, that is completely not how words work. It's just not how language works. Okay. We're getting almost done. Okay. No one ever wants to think about this. I have no people like us with liking to explore reality and thoughts and science. They have no education for? It's not about education. It's about humility. It's about like, and humility just means honesty with oneself about oneself. It doesn't mean fake humility of like, there's no way I could have figured out the foundational theory of existence. I couldn't have deduced the fundamental nature and structure of reality or of existence. That's not humility. That's like politician fake humility, posturing fake humility. True humility is honesty. And there's a part of in the Bible, in the Torah, which is the first 5 books of the Bible, where it says Moses was the humblest man in the world. And you're supposed, if you believe in that the Bible is true, super literally true in many different ways, not just historically accurate, not just metaphorically true, but like metaphorically, historically, morally, all kinds of different ways, which is how Scripture is meant to be interpreted. But it says Moses is the humblest man in the world. What's funny about this is that the narrative is that also Moses wrote the Torah. I mean, it says that it God, it's from God, but through Moses, like God told the first 4 books of the Torah to Moses, and Moses, transcribed them. That's just how it's described. If you're not a theist, that's going to sound insane to you. If you are a theist, then you understand that that's not as insane as it sounds to somebody who is only taking it within to mean what they would think it literally and historically meant in the way that they can conceive of it, verbally and things like that. What it basically means, though, is that like, if it came from God, it's assumed to be the truth. But it's also Moses who wrote it, and then Moses supposedly wrote the last book, but it's all kind of assumed to be true. But what it really means is that if you watched this happen, you would just see Moses writing, and then you'd read what he wrote, and that is supposed to be, allegedly the truth. And in it, he wrote, Moses is the humblest man in the world. So basically, it'd be like Trump writing in another book and writing in it, Trump is the smartest man in the world, and in the third person. Or like, it's even funnier if it's Trump saying Donald Trump is the humblest man in the world, written in the third person by Donald Trump. But again, this book is supposed to be the truth. And Dennis Prager said, he's like, this is so funny when you think about it. And he said, there's only one way that you can believe in or trust in the Bible and have it make sense, and that Moses had written this. And he said the only way that makes sense is if it's true, is what he said. It's like, not the only way that the Bible is true, and for Moses to have written Moses is the humblest man in the world is if it is true that he was the humblest man in the world, and that he still was the one that wrote it down. And the thing is that there's actually a deep lesson in here, like a profound lesson. I don't want to say deep, but like a really important lesson, regardless of what you think about it, but just the logic of it, regardless of what you think about religion, is that it's a lesson about humility, is that humility, if you're the best philosopher in the world, if you genuinely think that doesn't mean that nobody else is able to philosophize on things that you can't. It just means, like, maybe you're the most skilled philosopher in the world, or you're the fastest man in the world, fastest runner in the world, or the strongest person. You can lift more weight, bench press more than anyone else in the world. If you truly believe that, you should be like, I probably the best bench professor in the world. I'm probably the fastest man in the world. Like, imagine if Usain Bolt was like, I'm not really the fastest man in the world. It's like, as far as we know, you are. Actually, that's just the case. But the humble thing would be for him to be like, yeah, I seem to be the fastest man in the world. If he said, no, I'm not, that's not humble. That's actually dishonest. And dishonesty implies that you think that there's some kind of goal that you have with this communication that is more important than the truth, which is the opposite of humility, actually. It's very interesting how like warped our perspective is, certain terms. We're about to have a term completely warped and the definition of it destroyed by the AI like craze, which are really dynamic network algorithms. That's all they are. I call them DNAs, dynamic network algorithms, because that's an accurate description of what it is, not AI. It's not an accurate description of what's going on. Necessarily. It might be if you could agree on the definition of artificial intelligence, but let's look up artificial definition. Means artificial if it's made or produced by humans rather than occurring naturally. It also refers to imitation, substitutes, or things designed to replicate natural qualities. A single word cannot, by the way, also have two completely different definitions. It's funny, if you look up what the definition of synonym, it will say the definition of a synonym is two words that have the same meaning or two words that have very similar meaning. By the way, those are two completely different definitions. Two words that have a similar meaning is just two words that have a different meaning from each other still. They might be related. They're not similar, they're related. And but two words with definitions that are related are not synonyms. Nobody would say that. And two words with the same definition doesn't actually exist in any language. At least definitely not English, but I don't think it exists in any language, because the logic that is responsible for it not existing in English exists in every language. So it's funny because like when you look at the definition of the word synonym, it gives you two different definitions that are contradictory. It's just, that's how kind of warped we've become. But artificial often refers to imitation, substitutes, or things designed to replicate natural qualities. Kind of an imitation. So let's look up now artificial etymology. Now we'll learn the original definition. Root word for artificial comes from the root word aris, meaning skill or art, and facer, meaning to do or to make. Rather, they formed the Latin artificium, literally translating to made by skill or human made rather than occurring naturally. I think that the term artificial is artificial. I think that it's kind of a nonsensical term. Like, there's a dove with a nest in the tree outside my house, and it made that nest. Is that nest artificial? Is it possible for a nest to exist artificially? Or is it possible for a nest to exist artificially or naturally? Or is it just, it's either natural or artificial, depending on your definition of artificial and natural? I think that we are wrong. I think that we're so divorced from the context of that gave rise to the term artificial. We came from a time where like so much was
Like there was, when the term artificial was created, there was no electric light bulbs. Okay, guys, there was fire, and that you could use for light at night, and there was the sun in the daytime, and the moon sometimes at night, and stars. It's like, which of those sources of light is artificial? Is a fire an artificial? Is like a campfire an artificial source of light? I don't know the answer to that. I think it's a bad question, is the reality. So now we're trying to apply, like, I don't know. I think our context of our understanding has changed. That doesn't mean actual context has changed. It means like the limits of our perception has changed. We're so integrated with technology now that we don't feel at the mercy of nature very often. So we don't really think of like nature versus what's natural, versus what's artificial. Nature just means like outside of the city to us now. It's like out in nature. I don't know. I got to think more about like what would be the best definition, but you'd have to look up the definition of nature. Is a house artificial? Like a house that you build? Any house? Why not a hole in the ground that a mouse digs? That's all we're doing. We're just, skyscrapers are human hives. They're just hives that humans make. And just like bees make a beehive, a skyscraper is a human hive, motivated by instincts and abilities, and some, passed on behavior, social behavior. Same as bees. It's really no different. It's just, we can just apply it in more abstract contexts, but we're not talking about abstract context. We're talking about housing. That's a natural context. Bees make hives based on what is available, just like we do. I don't see the divider between nature and humans, the way that it would be applicable to the term artificial, to how we use the term artificial today. But the term that the AI field is about to corrupt is agent. And it's not just the AI field. It's not the field of study that's corrupting it. It's that it's a marketing term. AI agents. Every single company that I see nowadays has an AI agent to help you. Guys, if you called any pharmacy in the last like 20 years, and it's like, I can, press 1 for the pharmacy, please say your name, your full name and date of birth, so I can check your prescription or something. It's just a program. It's the same thing. It's just, instead of being updated intentionally one time, it's just built into an interface that's networked, that is constantly updating. That's the only difference between like an LLM, an AI agent, and like what Walgreens and like CVS run when you call their stores. It's just how often is it updating and who's updating it. Dynamic network algorithms are the future of software, way beyond any program that we go to, like an LLM like ChatGPT. It's like I got an update to Adobe. Used to buy Adobe programs like Photoshop when I was studying photography in school and more involved with photography professionally. Still, even, you would buy the program on a disc, and then you would download it onto your computer, and you could buy it, the next version, the next year, the next year, the next year, and it's very expensive because once you owned the software, you owned it for life. But then everything's turned into a subscription-based thing now, because it allows for them to make constant updates, and it also leads to a constant source of revenue, because I never paid for Photoshop before it was a subscription, because you always found a friend who had like a bootleg like disc, and they could give it to you for free, and I got it. And, I remember it was like amazing every time I found somebody with a new version of Photoshop that they could give me, and I didn't have to pay hundreds of dollars. Now it's like $30 a month, this but all software, but it's updated every time. It's like same thing as your phone, where like it's like iOS, 13.7, 13.8, 13.8.1. Every update is intentional by the company. Eventually the company in some way, and the software that is iOS will be like a dynamic network algorithm that is constantly updating. One person finds one issue and talks to the LLM that is Apple's LLM, and if it is able to interpret or be convinced, I don't want to say convinced, but steered. If the algorithm is, if you're able to use logic to steer the algorithm towards correcting a certain way, then it would just make the correction to the software, change something, improve something. It's the future of all user interfaces, and all software is what we call AI today. It's not just like that there's this Claude and ChatGPT. It's like your iOS itself will, not Siri, your entire iOS will be constantly updating network algorithm. It's fascinating. But AI agent. It's not an agent. If it is an agent, then it changes the definition of agency, and now we don't have a definition of agency. Which, how do you have a definition of morality without agency? It's or sentience or consciousness or someoneness or value, meaning. It all falls apart. It's really probably going to be the worst definitional shift in human history, will be the corruption of the term agent, because it's been placed in the context of marketing, the marketing of a product, which they never make new terms usually when they're marketing a product. They because it feels artificial when they do, because it is. Okay. I know it's past 1:15. You are so awesome. Thank you. I appreciate that. You are awesome. Thank you for being here. I do have to run now, heat and all. I would not leave a second before if it was not necessary, life and death. Now Thursdays will be sacred to me, and I'm up all night too, so whatever time I try and catch you. I'm up very late on Thursdays. I try and work on my theory, and I plan for next week's stream and stuff, on Thursdays. So I'm usually up very late after this even. I can't just go straight to bed. But sleep is important. Even sentient singularity theory has implications about what sleep is and why it's important, and why it's important to our memory. Of yourselves. You're the boss. And every time that you say, grab that water bottle, and your entire arm, every cell in your arm goes and grabs that water bottle, they can't do multiple things at once. And they can't focus on multiple things at once. They are going to focus on what task you are commanding while you're awake. And that means that they can't focus on themselves, because they're focused on you. They're focused on doing what I want, not what they want or what they need to do. They're focusing on what I need to do and what I want to do. I need to drink water. I want to, I don't know, watch TV. So my eyes, all the cells in my eyes have to focus on it. But imagine if you were at work, you were working all the time and you never were let off work. What would happen to your house? What would happen to your body? What would happen to you? You could never stop and eat, and just eat and rest and clean up your home. That is what's happening every time you go to sleep. It's you're basically letting your cells off the clock so that they can focus on creating order within their space and taking care of themselves. Because when you're awake, they have to take care of you, and they're focused on creating order within your space, not within their space. And creating order within at your job, but it's leading to disorder in your home, and you need to stop focusing on creating order at work in order to focus on creating order at home. And this is what happens when you sleep, is you're letting your cells do what they want and what they need to do, instead of what you want and what you need to do. But it's that alternation that is it's requirement for any kind of sustained action. Yeah, it's basically like it helps you kind of reverse the entropy, the cellular entropy. So it's very important to sleep. I never realized that until Sentient Singularity theory. I was like, why sleep important? I've always been a night owl, and obviously you need it because eventually you feel it. But what is happening? That's what's happening. But that is understanding that is in the context of sentient beings nested within other sentient beings. That's the context that gives you that understanding of sleep. Why is it important to long-term memory? Because every time you go to sleep and wake up, it adds a contextual marker. That's why if you pull all-nighters, you can never remember what you had for breakfast, because you don't have any delineator between your last breakfast and the breakfast before that one. You don't know which one. It's harder to realize immediately which one came when. You can think about it, but you have to sit there and be like, okay, I did this a few hours ago, and before that, actually, I did eat this for breakfast, which means that I ate that other thing for the breakfast before. But if you sleep, then you're like, yeah, I woke up and I ate. When I woke up this morning, I ate that. And when I woke up yesterday, I ate that other thing. But you don't have those contextual references. Yeah. But so we're going to go till 1:30, and then we're calling it. I feel bad when I stay up when these go too late, because I feel like it's not fair to the people who are watching, even though most of the people don't watch live. But it's the people who watch live that I care about, and the most. I still care about you if you're watching this. It's not live, but I don't care as much about you. I'm just being honest. It's just you're just not as real of a person. You're a view on a counter if you don't watch this live. If you comment down below afterwards, it adds to like your personness to me. But if you're not watching live, then and into commenting in the chat and liking in real time, it doesn't feel like I'm talking to someone. It feels like I'm talking to myself and then sending it to other people, which is cringe feeling.
Getting everything all at once. And even if you don't actually observe everything all at once, which we never do, but everything you do observe is a subset of that. And what that opens up the possibility for is this thing called entanglement, where let's say I have two particles and they're moving in opposite directions. But I don't know what directions they're moving in. All I know is they're opposite, right? Therefore, if I measure the position, the direction in which one of these particles is moving, I get a probability, right? Like I don't know exactly what I'm going to get. But I know that once I measure that, the other one's moving in directly the opposite direction. That's entanglement. It's a way of saying that we don't know exactly what the outcome is going to be, but given the outcome of one thing, it's related to the outcome of the other thing. And in many worlds, we take advantage of that. This whole entanglement thing was really pushed by Einstein back in the 1930s, and he didn't like the Copenhagen interpretation of quantum mechanics. People think that Einstein didn't understand quantum mechanics, which is entirely untrue. He understood it as well as anybody, honestly. He helped invent it. What he didn't do is think that it was finished. He thought we needed to improve it, and people like Bohr and Heisenberg and Pauli were saying, no, we're done, let's move on to other things. So he wrote this paper about entanglement to say, like, surely you don't think that this is what's really going on. We need to do better than this. You're telling me that the outcome of an experiment here could depend on what's going on Alpha Centauri, 4 light years away. That seems unlikely to him. Many Worlds makes lemonade out of these lemons and says, no, this is exactly what happens. Entanglement is there, and what happens when you measure a quantum mechanical system is that your part of the wave function becomes entangled with the part of the wave function that describes the system. And again, this is nothing more or less than what the equations predict. All that Many Worlds asks is that you take the prediction seriously.
So
He says take them seriously, but I don't know what that means. I think anybody engaging with this is, I'm going to assume, is taking it seriously. But I don't. I mean, it's hard though to say that because I don't think he takes theism seriously. But he takes it seriously enough to think about like the logic of it. But the problem is his definition of God is incorrect. That's the problem. It's not different from mine. It's incorrect. You can't. If somebody says, I disbelieve in the existence of airplanes, I do not believe that they exist. But I do believe that they exist. My definition of airplane is the one that matters, not your definition of airplane. And if your definition of airplane is different from mine, it's my definition that you must assume is the definition, because there's no reason to have a term for that which does not exist. If you believe in that something does not exist, there should be no term for it, logically. So, like a unicorn, it does exist in stories. It doesn't exist, in as a horse with an actual horn on it, in nature today. But rhinos exist. I went and saw one, and it's funny. I went to a bar that had a rhino in it. At it. It's a rhino breeding facility, or it's a rhino conservation facility that is also a bar in Texas. I went there for Father's Day. It's all rhino. It's pretty cool. It's called the Rhino-Ree. I definitely recommend going if you're in the area. It's pretty cool. You don't have to drink. My wife is pregnant. I don't drink. She doesn't drink. We walked up to them. I was like, we don't drink, but can we see the rhinos? And they were like, yeah, we have one rhino here right now. Just go on back. And it was a very nice place. So the winery, it's the Rhino-Ree. Cute. But it was cool. That's basically the closest thing though that you're gonna have to a unicorn. But a unicorn exists as like a fictional thing. It just doesn't exist as a real animal. And that's two different contexts. So, we could say flying cars. Do flying cars exist? It's like, yeah, in fiction, but in nonfiction, we call them something else. But basically, a helicopter is a flying mobile. But it's it's interesting when people said in the Bible, it's in the Quran actually, it says in the future there will be, I think it's in the Quran, it might be in Hadith, but Muhammad basically made a statement that like in the future people will ride inside the bellies of donkeys that are powered by fire and soar faster than the clouds with their ears outstretched wide. And people will be like, flying donkeys don't exist. But donkeys were the transportation method at the time. Remember the context. That's basically like saying, in the future, there'll be flying cars. Before an airplane was invented, imagine if somebody said, in the future, there will be flying cars. Like cars will fly. And nobody would be like, no. I mean, maybe some people would be like, no, probably not. But but basically it's just saying like there will be a mode of transportation that flies in the sky eventually. But then we did make them. They're called the aeroplane, and the helicopter, the quadcopter, the sexicopter, whatever number of rotors it has. We are getting closer and closer to like much more common personal transportation that's, flying. And it'll be more like taxis and stuff. It'll be like Waymo, but it'll be like quadcopters that are Waymo that you just order and they come pick you up and you get I don't think everybody's going to have like one of their own that they can drive around. Doesn't mean you can't. Nobody will. People do it, are having them now. Like black fly, but we don't call them. It's funny. Black fly is such a bad example. Such an interesting example. I don't even know if that's because they keep changing the name of their company. Now they're calling Pivotal. And there are some people that actually own these, and like you can fly them, and they're like, "This is the flying car." Well, I mean, is it really different from a helicopter? Because it's not really. People have helicopters and Cessnas, personal planes before this, but we never call these flying cars. We just like they never called donkeys that are powered by fire. Fire donkeys. They called them automobiles. And then when they flew, they didn't call them flying donkeys, flying fire donkeys. They called them aeroplanes. And but before that, they exist, and we see kind of their attributes. We just know the capability, and we're like a flying car, a flying donkey, and it's just interesting to see like how much context changes these things. Our interpretation of these. Love and respect always, friend. So sorry, I must leave. We'll listen to the rest when I get back. No worries, I went very long.
It's nothing that is really built into the fabric of reality.
And I want to drill down on this concept of measurement, right? So in at least the way that I was always taught physics is that there's a very clear division between the experimentalist, this kind of anonymous scientist doing the experiment, and then the apparatus that they use, as well as the thing that they're observing. There are very clear boundaries between each. But quantum mechanics kind of blurs those boundaries. So tell us just like what is actually going on here.
Yeah, it's super important because the idea of measuring something, that's an old idea. That was not invented for quantum mechanics, right? But in classical mechanics, which is the picture we had before quantum mechanics, it wasn't something you had to think very hard about. Like there were things and you could measure them. That was it, right? If you have a ball moving through the air, it has a position, it has a velocity. In principle, you could measure them. And you might think, well, when I measure it, I'll disturb the system a little bit. But that's not a real fundamental worry. You're just a bad experimenter if you disturb it too much, right? You could work very hard and disturb it an arbitrarily tiny amount. Something new happens when you invent quantum mechanics, and the word measurement starts taking a place in the statement of the fundamental laws. There's no word measurement or observer in classical mechanics, in relativity, in Maxwell's equations, or anything like that. But in quantum mechanics, it suddenly appears. So again, we start asking questions. What does that mean? Can you represent the observer, the measurement, as a physical process using the ordinary laws of physics? So you're right that in ordinary physics,
the entire issue is the depersonalization of everything. The observer is actually a measurement, which is actually a device, which means that it doesn't have to be a person. And he asks these questions. He's like, can a cat make an observation? Does it have to be a person? Does it have to be a human? Can it be a camera? It's like, this is why sentient singularity theory is so important, because sentience is the context. It's not about, is it human? Is it not human? Can it be a cat? No, sentient being, someone can be an observer. When they are observing something. And this has led to just so many issues, because the issue is not actually even the use of some of these terms. It's the depersonalization of their definitions, and then the stripping of their personal context, of the subjective context of these terms, like observer, observation, measurement even. And we use the term measurement as a kind of a synonym for observer and a synonym for observation, which is like, why are we doing that? And then we can't agree on what it means and what's going on. It's like, your terms are screwed. They're screwed up. They're just nonsensical. And nobody's thinking about this in kind of a straightforward way. And so I have this thing. Let's look at this real quick. So here, he's talking about the Copenhagen interpretation here. I jumped all around.
Really?
I know that the stream was kind of not what as coherent as I had expected it to be or wanted it to be, but I don't even know if that's true. I wasn't as focused on the clips as I was planning to be, but I think that's fine. Let me know in the chat what you think.
More, just so you know, there's this famous way of thinking about quantum mechanics called the Copenhagen interpretation that basically says exactly what I said and says, that's it. Stop talking, we basically know it, just like you said. You have a wave, the wave function of the electron, until you measure it, and then the wave function collapses, and the kind of collapse you have is very special. If you measure a certain quality of the electron, like its position, or its spin, or its velocity, it collapses to a definite value of that. And a miracle of quantum mechanics embedded in what we call the uncertainty principle says a definite value of position is not a definite value of velocity and vice versa, and that's a whole other story. And this is basically what we teach our students. The electron is a wave until you measure it, then it collapses. You can't, sadly, say exactly what you will see when you measure it. You get a probability of seeing different things. So you're already in this slightly weird position where the way you describe the physical system is in principle unobservable. You describe it using a wave function, but you can never see the wave function. When you measure it, you see a position, okay? So why isn't that good enough? There's two problems, and they're both very big problems that you'd become very famous if you solved them in a way that convinced everybody. One is the measurement problem, and that's because in that description, we used the words measure or observe, right? Someone in your class, when you're teaching quantum mechanics at the back of the room, is gonna say, okay, but what is a measurement? When does that happen? What counts? Yeah. No one knows. Nobody has any idea. It's an undefined idea in the Copenhagen interpretation of quantum mechanics. Does it have to be a person doing it? Could a cat measure the wave function? Could a video camera? Could a rock? Right? None of these questions are answered. When does it happen? How quickly does it happen? Is it sudden? You know, like this is not how a fundamental theory of physics is supposed to be. The terms are supposed to be well defined.
They are well defined. You just need to look up the etymology of the terms before you use them, instead of teaching them to your students without using without looking up the etymology of these terms. Like, what are you doing? I don't understand that. I just don't. This is what I mean by academia's parrot has just become like a game of telephone and of a bunch of parrots playing, and who are all telling each other that they're trying to understand the world, but really they're just trying to pass on, memorize and regurgitate information that, in the words of that they've been told, were determined and deduced and figured out by the people who were, being idolized as the founders of the field. And that's really what's happening. It seems like kind of just a rant about it, but it's actually also a description of what is actually going on. And when I was on that call with Eric Weinstein, and there was a couple other experimental physicists on there. At least one of them worked at CERN, and they were talking about the Higgs boson, and she was basically saying that everybody assumes that everybody at CERN knows what exactly what's going on, and that they really understand the world. And in reality, they don't, and they all assume that the other person working with them does, though. And so they constantly, everybody's just faking it, is basically what she said. And then they talked about how the Higgs boson is nonsense. And there's many people that think that, though, and I'm one of them. Even Stephen Wolfram, he said it's a kludge. It's a kludge, and it is. It 100% is. I realized that when I was first started studying the Standard Model. I was like, this is a kludge. because we're assuming that that there's a tiny particle called a graviton that exists, and if we're assuming that, then we have to assume this, and if we assume that this, then we assume that, and that's basically what's happening. And I'm not saying they didn't measure something, but I'm saying that they don't understand what they measured. That's all I'm going to say. Not saying they didn't make a prediction and then measure it. That's not the point. I'm saying they don't understand what a particle is, and then they're going to claim that they found the Higgs boson. No. Sorry. Don't tell me you don't know what a particle is. And they do say that, by the way. And so... and I'll show you that in a minute. So here's the thing. When he says the measurement problem, if you solve the measurement problem in a way that convinced everybody, measurement problem, then you would solve such a huge problem in physics and be super famous and get a Nobel Prize or whatever. The measurement problem is a fundamental puzzle in quantum mechanics. It asks why and how a quantum system which exists in a superposition of multiple different possible states exists in a position of multiple possible states. By the way, that statement doesn't make any logical sense. You can't exist in possible state. There's possibilities that are possible in a specific given state, but they're not possible in that state. They're possible basically as subsequent states after that state. So, if you're over here, then you can, if you're on that end of the street, then you can turn on that street or that street. But if you're on that street, then you can turn on that street or that street. But you don't exist in a possible space of being on all streets. It just doesn't, grammatically doesn't make sense. But instantaneously settles into a single definite outcome when measured. How and why? You know why this problem exists? It's only a problem for one reason. Because the context of sentient being as the the defined observer, and the context of a sentient being being the observed is dismissed. It's not even proposed as a possibility. There's this interpretation and that interpretation and that interpretation and that guy's interpretation, but none of them are like, yeah, we are a being inside that is dynamic and inside of another being that is dynamic, and we're both moving, and I'm also composed of a bunch of beings and that are all dynamic, and I'm making an observation on like a fundamental scale. In that context, nobody says that's the context. I can't even remember what the Copenhagen interpretation is versus the Bohmian interpretation, because every time they say it to me, it goes in one ear and out the other. And the reason why is because none of it actually has any substance to it that clings to reality. You know why that's definitely true? Because none of them have gone on to become the accepted interpretation. Think about what it would be like to observe a world that is fundamentally in motion, meaning you're inside a being that's moving, and you're composed of beings that are moving, and you're trying to see what the velocity of the motion of the universe is right there, and what its position is right there at the same time. And you can't even do that because those are two contradictory questions. So I have this thing. This isn't for show or for a weird effect or anything. It's a piece of kinetic art called the Kinectrica that I got many years ago before I started this channel to try and help me explain the superposition problem, the measurement problem. So the measurement problem is when they say things like it collapses, the wave function collapses. That is a bad term. It implies that something about the world is happening but really it's described in the context of an equation. An equation is not the world. And it allows us to make predictions about the world. Sometimes they're almost like 100% accurate. Sometimes they give us probability, and it depends on where we're applying them and what the context is. But imagine you are looking at a wave through a telescope that is so zoomed in that it only lets you look at like the smallest possible observation, level of observation, or speck of ocean in this wave at a time. That's how focused in you are. And you're looking at a wave, and you're going to try and look at it, make a measurement, and you're going to see a point. Okay? And that point of focus comes from your own mind, and the constraint of built into the definition of focus is that you can only focus on one thing at a time, because that's what focus means. And when you focus and focus and focus, and in certain contexts, it's going to lead to kind of on a quantum mechanical scale, which is not even a good term either, because this is not about size. It's about the constraints of mind and the questions that we're asking, and the context of where we're looking at the universe when we're looking. So when we're looking at the electron wave function, and then we can't determine its velocity and its position at the same time. It's like, no, you can't ask to look at both of those things at the same time, just like you can't ask how fast a wave is going on the at the beach. Is it going 20 miles an hour? Is it going 10 miles an hour? You can't ask that question and simultaneously ask what its position is. Like, how far is it from where I'm standing on shore? And how fast is it going? You cannot simultaneously observe in one observation, get enough information to have the answer to both of those. And that's because its position, its velocity can only be measured as it's moving from this position to another position. You know, how fast is it moving from towards me? Okay, that means you're looking at it moving. Your focus is on its movement, which means your focus is not on where it is now, in that moment, in that instant. Your focus is on how fast it's moving towards me. Over the course of many moments. Those are two kind of like opposing questions. One of them is how fast it's moving, and the other one is where is it now? And you're asking to make a static observation. You're not asking if it's moving. You're asking where is it located now, which means you're observing it in a static state. But if you're looking at its velocity, you're not looking at a static state. The same thing goes with the observation of a wave and a particle. When you're looking at a particle, it's really a point. It's a point on a wave, okay? And which is a larger structure that is moving. That's what I mean by wave. And when you're looking at a point on a wave, and the constraint of focus, that is, the constraint of mind itself, basically, is that it requires you to focus on a single instance, which is going to be, in a physical context, interpreted as a point, which then we assume is but it's not a particle in the way that like a grain of sand is, where I can pick up the grain of sand and move it. You can't do that with like an electron, really. An electron is a point on a wave, which is really just a larger structure that is the universe itself moving, and you're looking at a point of it. And that's it. You're focused on one point, and you're calling it a particle. but it's a point. And all the elementary particles are points, called quarks force points. They're points of force being applied by the universe itself, not by us, by the universe itself. And you know, a neutrino is probably the observation of a point of the universe that is, you know, in a different context than like when we observe an electron, which is a point in a different context. And what those are, I'm still thinking about it, but I'm almost definitely right about them, about what I just said. And the first time you get a particle or anything that is like kind of a separate self-contained structure would be a sentient being, because a self-contained information system, meaning self-referential, within the universe itself, which would be a proton and a neutron, which are composed of points, but of force points, you could say, or maybe that's not even the best way to put it. Maybe they're constructed of force points, but they are also one, which is not a construction of multiple force points, but their mental structure, which is their body structure, which is your body and your mind are not two different things. Really, your body is part of your mind. You are a mind. You have a brain. Anything that you use for information processing within the context of your will is incorporated into your mind. Yeah, you have a brain, you are a mind. But like, this is what's actually going on. This is why you can't measure from a single observation a particle's position and its velocity, because you're asking two opposing questions. One of them is, where is it right now, which is now is a static state, not now, just now. But with velocity, you need now. It relates to like another structure, and you're not asking where it's located. You're asking how quickly is it moving towards a defined location. But that defined location is not it. It's just how quickly is it moving there. They're two different questions. This connectricon helps to explain this, and then I'm going to wrap it up because I think that's it. There's a lot that I wanted to cover. Maybe we'll show more clips later, but you know, it's really important. He said this is the kind of the bedrock, the most foundational thing. And I will also say, don't think of quantum mechanics as the study of the very small. It's the study of a specific context of dynamic systems that are singular. Okay? Interacting with each other. That is what quantum mechanics is. Think about quantum mechanics. Quantum means quantity. It doesn't mean small. It means quantity. It means which means singular. Quantum mechanics is the study of sentient interactions. The interactions of sentient beings. Whether Sean Carroll wants to, give it actual serious consideration or not. But if I ask you about this, imagine there's this thing that is constantly moving. This is it, this connectrica. And a connectrica is never still. I asked you, do you see the square? The answer is yes, you see the square. If I asked you, do you see the squares, multiple? The answer is yes, you see the squares, multiple. If I asked you, do you see the wave? The answer is yes. If I asked you, do you see the helix even in the center right there? Right there. The answer is yes. And It's just which question are you asking? So what is this? Is this a wave? Is it a particle, meaning square? Or is it a bunch of particles? Is it particles, many squares? Or is it kind of a helix, which is the fundamental information structure that you see looking at an information structure from it within it, which is why we see DNA, and even numbers are arranged in a helical structure. It's just the structure of a blockchain. It's a blockchain structure. That's what also like blockchain, like cryptocurrency blockchain is the same thing. One of them is digital. One of them is, you could say, metaphysical, which is numbers. And the other one is chemical, which is DNA. If you don't believe me, I can show you it in numbers right here. And then I'm going to call it. So this, if you're looking at information structure, the center of an information structure, which means like where the growing is happening, where the construction is happening. From the inside, you will see a helical structure, and because it's what happens when you're building information on top of other information, but that information also has to reference the previous information. It's a self-referential constructive information system forms a helix. Like a dog chasing its own tail is self-referencing, but a dog chasing its own tail and growing is going a certain direction while it chases its own tail. But if you look at this is a spin sequence. These are spin sequences and numbers, which are, like the Fibonacci sequence. They're just sequences that reference previous, are contextualized by the previous number. That's true of all numbers as well. But you really need to look at it on such a crazy zoomed out scale to see that, to see the helix in that context. But I'll show it to you here. And this is a self-referential system where sequence of numbers where it's referencing this, which is got an equation here, and even here, G12, that means it's referencing the previous one and going through some mathematical numbers. So, but you can see here, this is kind of what we end up with. And I'll explain why I was doing this another time, but look at it when I move it. Do you see the braided pattern? That's why this book about fundamental information, that's really what this is about. An eternal golden braid. That's what information is. It's an eternal golden braid. Golden means eternal, so because it doesn't tarnish. So I don't know. It's like saying eternal braid, but maybe you could say it's eternal beautiful braid. Look at that. Can you see it? Let me know in the chat or in the comments section if you see that. But I mean, I think you should right here. It's a helix. And if you took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and you laid them all out and you zoomed way out and you visually placed it so that you could see it all at once, and then you kind of moved it just like I just did, you would see a braided pattern in it, which is wild, but also inevitable. But that's the question, is like, is existence, the structure of existence, is it singular? Is it multiple? Which kind of is singular. If it's multiplicity, then it means it's singular and multiple. It doesn't, it means lots of singularities. It doesn't actually, it's not in opposition to singularness. It's kind of built, it's required that that the first one is true. If there's squares, then there is a square. But or is it a wave? Meaning, is it information? Is it moving? Is it dynamic? That's the wave. Is it singular? That's the square. Is it does multiplicity exist? That's the squares. Is it informing? That's the helix. And it's all four of those. And you can see it in this. So when you ask yourself, what's the velocity of an electron field? I don't know exactly if that's the right way to state it, but of an electron. But you're assuming it's kind of like a field in that way. Just like you're assuming it's a wave, that's what that means. And what's the velocity of it? Well, you can answer that question. What's the position of it? Which really means what's the position of it and my observation of it? Like, that's what that means. Because you're only looking at a point on the wave. You're not looking at the wave and then trying to determine its position. You're saying, what's the position of the wave and the intersection point between my observation and the motion of the wave, which really just means the motion of the greater structure. It's like when you move your arm, when I move my arm, the whole world moves for my cells. The whole world. And imagine they were trying to like locate the position and measure the velocity of their world, of my arm from inside my arm. But they are moving when I move my arm, and the greater arm is moving. And so like this is the context of this that this measurement is taking place. So you're not even measuring the location of an electron. It's that what you perceive, what we call an electron, which is a point. We can call it an electron point. That's probably much more accurate than saying an electron particle. It's particle, and just implies it's separate from a greater structure. Like you can particle of sand, but it's not a particle of sand. It's like a point on a lava flow that we're looking at. It's not separate. It's like a molecule of the rock in the lava flow in a weird, but it's like not separable from the lava flow. It's not a particle. It's not a molecule of the lava flow. That's not a good analogy. It's a point on the lava flow that we're looking at. Just really zoomed in. And but not to the point, actually not to the point of a molecule, because that's when we'll start seeing individuation. But that's real, but not, you won't see it in an electron is not actually. Yeah, there's this theory that I hear people reference sometimes, like one electron universe. That's not a good idea, because it's like, then just call it the universe. but then it's like, if there's an electron field instead of little electron particles, what we really should call these electrons are points. They're focus points. They're points of focus where we're focusing on kind of like fundamental movement in the universe. That's it. Let me know if that makes sense, and then I'm calling it. Like it, I don't see this measurement problem as a problem. I think that the problem is all the definition and context and assumptions and presuppositions that divorce intentionally and unintentionally someoneness from any of the context that we're assumed in that's assumed in quantum mechanics is the problem. And like if everybody's trying to solve this problem, like the measurement problem, and it's a problem involving fundamental reality, it's not like a math equation even. It's like there seems to be a philosophical issue with this, and the problem is philosophical. it implies that the problem is the quote unquote problem. The question you're asking is, and what you're trying to do might be impossible. It might come from a misunderstanding and you might be missing the context that you need to actually understand and ask a better question. And that's what's happening. Like, it is that simple. It doesn't also change that, like, I'm not telling you that no understanding this is all of a sudden going to make you, able to fly or something, invent anti-gravity. Maybe it could lead to that eventually, but like, you're going to need additional context if that's even possible. But that's not, the point. It shouldn't be just like profound. It should be like intuitive and be like, yeah, that makes sense. It should be kind of almost like, okay, sure, that does make sense. It shouldn't be like this profound thing of like, I have, with this equation, solved the measurement problem. You can't solve the measurement problem with an equation. You need to understand the context that our observation is taking place, to understand the observation that is being made, and the constraints and degrees of freedom when it comes to making certain measurements in certain moments. Then you can start thinking about experimentation. Then you can start thinking about application. But like, first you need to figure out your definitions and your context. And this is what physics is missing. It really is like a language problem and a dogma problem. A lot of assumptions are made that without any true context or understanding, even by people with PhDs. And Sean Carroll knows that, because he said that nobody can agree on the definitions of terms that we've chosen to use. But the thing is, they didn't choose to use them. They're choosing to continue to use them despite not understanding why they were chosen. And then they're assuming that just nobody understands what it means to make a measurement or what the definition of an observer is. That's so frustrating. Just look at the etymology, guys. Go back to basics. Anyways, with that, I'm going to call it. I would suggest, since I didn't get through nearly as much of what I wanted to with this, of the clips that I wanted to, I would suggest watching their entire discussion, because it is very good. And I think that, what's her name? Jacklin Kwan does a great job asking questions, and Sean Carroll actually does a great job answering. As great a job as he can, I think, right now. But just recognize that, like, some of the things that he says hold some serious implications about how physics, about issues in regarding issues and how physics is taught, how it is assumed to work, and also how it is communicated. Like, we have a language problem more than anything else, and if we don't get the language right, we can't ask the right questions, and we can't get the right context, and that means we cannot understand. We'll just all argue about whether or not Bohm's interpretation, or the Copenhagen's interpretation, or Sean Carroll's many worlds interpretation is correct, or whether or not there is, what the definition of a measurement and an observer and an observation is, while we're claiming that there's a measurement problem, and we're using the terms in our questions and our definitions and our explanations that we also claim to not have an understanding of what they mean. It's just that much chaos. Anyways, Thank you, everyone. Peace. Hit the like button.